Hello everyone. Welcome to the Community Resilience Shelter Division. My name is Srijit Jairam and I'm the jury coordinator for this division. It's my job to keep us on time and I'll be taking this very seriously. Our finalist teams have done some amazing work. So let's get ready to have your socks blown away. So the Community Resilience Shelter Division has 3 jury members with industry expertise in net zero and resilient buildings. We have L. Venkatesh, who is the Director for Integrated Digital Delivery at Invikara. Hello, Venkatesh.
Hello, everybody. Good morning.
Next, we have Vinay Natarajan, who manages the Building Science Research and Development at Saint Gobain Research India. Hi, Vinay.
Hello, good morning. Hi.
Our third jury member is Anamika Prasad, who is the Director of Environmental Design Solutions. Hello, Anamika. So these jury members have had over 2 weeks to look at your reports in detail, and they have already assessed your entries for the 10 contests of the decathlon, and your presentations will help them hear your narrative, and they will assess your presentation and your mastery over your solution through the Q&A session, which is going to be followed by the presentation, and they may revise their scores based on what they hear from you today. So our first presentation is from Team Stellar, and they have worked on Vihan in Mumbai, and their project partner is the Municipal Corporation of Greater Mumbai. So let's just quickly do an AV check for the team. So hi Utkarsha, can you turn on your mic?
Yeah, hi, good morning.
Yeah, great. And hi Manan, could you unmute
Hi,
yourself?
good morning.
Yeah, good morning. And yes, loud and clear. Aditya, could you unmute yourself?
Yes, good morning.
Yeah, good morning. And Manav,
Hello, good morning.
good morning. Okay, so team, could you share your screen and go into the slideshow mode?
I hope the presentation is visible.
Yes, it is. Could you go into slideshow mode?
Yeah, I'm already in that.
Yes, great. Okay. So team, you'll have 25 minutes to present your work to the jury. And at 20 minutes, I'll ring a signal like this. Did you hear that? Yeah.
Yeah.
So you won't have a 26th minute. So which means at 25 minutes, I'll have to stop you there and ask you to end your presentation. And after that, we will have a 15-minute question and answer session. So keep your answers direct and to the point. Your project partner, unfortunately, is not here. So if he was, he could have given you some comments, but it's fine. So I think you guys can start, and all the best. The stage is yours. Yeah,
Thank
you
you.
can start.
So,
Yeah.
next. So, as we all know, Mumbai is the island city of Maharashtra and is like the financial capital of India. Some of the contextual issues Mumbai faces are like disasters, which include flooding, earthquakes, then lack of building space, large population density, and high cost of construction. Also, there is a lack of resilience centers in Mumbai, and there are only spaces allocated for gathering during times of disaster. Next. So our project Vihan aims to be adaptable to all situations, have a sustainable approach, be a resilient center to all common public, and be an equitable solution such that it gets constructed rapidly. Next. Our site is based in the G South ward, which in comparison to rest of the city is located at a slightly lower level, making it more prone to flooding. Some of the vulnerable locations in the site in G South ward are Varli Kolivada, the BDT Chawl area, the Prabhadevi station, the Kari Road, and the Dobi Ghat. Next. To give you some background of Varli Kolivada, it's one of the oldest settlements of Mumbai and is highly vulnerable to floods. For considering few locations as a location for the resilience center, we had options of Varli Gaon bus station, the Varli Sports Club, and the Varli bus depot. After consulting a project partner, which is the BMC, and addressing the issue of less amount of buildable space, Varli bus station was finalized as our location. Next. Some of the key statistics of Kolivada are: it's located in the seismic zone 3. It has a population of around 16,000. It has an area of approximately 0.3 kilometers square and is at an elevation of about 5 meters from the sea. Next. The site is surrounded by medium-sized buildings on all three sides, and the sun is incident upon the southern facade, providing adequate amount of thermal comfort during the day hours. The site, being closer to the sea, has prevalent winds throughout the year, thus making harnessing wind energy a bright opportunity for us. Worli Bus Depot is an active node at the site and is a point of travel between Kolivada and Mumbai. So it's like a point where people go to catch taxis and buses so that they can travel throughout Mumbai, and thus is an ideal location for resilience center as everybody knows the place. Site again is within 1 kilometers of the extremes of Kolivada, thus is very easily accessible and can easily absorb the panic-stricken crowd of Kolivada. The bus depot is located at an elevation. Our site is located at an elevation of about 7 meters from the sea level, thus keep making it more safe than the rest of Kolivada. Next. So after dividing the population into various groups and interviewing them about what their must-have requirements were, we decided that we will have a modular approach to the site, and we decided to use shipping containers. Next. So the major reasons we chose shipping containers was because Mumbai controls about 55% of the national maritime freights, thus making availability of second-hand containers quite easy. It's a modular solution, and thus the solution can be repeated in many places, and they are low maintenance and have a good structural strength. Next.
So coming about the modules, we have the industrial partner Transfabcon, which gave us some technical inputs about the modules. So these modules, all of our modules which we'll be presenting are almost of the same dimension, and being modular makes it much easier to construct. So we have the utility module, which includes lift, passage, and staircase, followed by the priority ones, which include essential functions like clinic, toilet, kitchen, and other modules, prefabricated modules, which are the dwelling module, office module, computer zone, and library modules. Now coming to the site, the total area of the site is approximately 848 square meters. And after doing a lot of site analysis, as Aditya rightly mentioned about each and every aspect of site, we then came down to the surface radiation analysis, through which we came to the conclusion that at an angle of 30 degrees from the north, we will be able to get the best orientation for our structure, and the radiation will be in an appropriate amount for maintaining the thermal comfort. As compared to vertical stacking, we again had segregated our spaces into two parts. The one being the very essential functions such as the clinic, the library, and the other being the community hall, the community spaces, lecture halls, which will be used as a makeshift spaces during disasters. And the bottom two floors basically are for the best and the substation and circulation cores. If you can see the other section, we have a predominant. So we predominantly have the sunlight facing the southern facade, which again gives us ample opportunity to give the libraries and all of these clinic spaces on that end. And on the northern facade, we actually have the majority of the wind current flows through that point, which if you can see, and via voids and other central atriums, we are able to let the wind flow into our structure, and these central open spaces facilitate the stack effect. Coming to the architectural planning of the structure, coming to the ground floor, we have the central space completely double-heighted open space for our bus parking, which was initially the function and which we have retained in order to go ahead with the structure as an amalgamation. So we have the resilient entry on one end, and on the second end we have the best office, the best the resting space for the personnel, and a canteen and a way to the canteen via the staircase is shown. Uh, yes, going to the first level, we again have the double-heighted spaces continuing above. We have the service floor on one end, which includes the battery room, the electric panel room, and the circulation core. And on the other hand, we have the canteen and the kitchen for the best officials, which will serve as a during the normal times of the day will serve as a revenue generating part of the building on a daily basis for the best workers predominantly. Coming to the second floor layout, we have this is where the main building starts. So we have the residence office just next to the circulation core as an easily approachable site. Next to that, we have the community space where, which is again open to sky, like open to double-heighted spaces, as you can see in the plans. With convertible dwelling units. By that we mean during resilience or during times of emergency, these can be actually converted into large dormitories of beds placed. As compared to as talking about beds, we have the storage space just next to that, so that the movement is facilitated quite quickly. On the southern side, we have the clinics with a waiting room in the center, and it is, as you can see, the approach from the circulation to the clinic and the proximity to the toilet again is all being shown properly. These are the views of the clinic and the clinic spaces and the waiting rooms. Here we have the view of the waiting room as an artistic impression as to how we imagine it being. Going to the third level plan, now we from the circulation area, we have these two spaces which have divided the entire floor plan into two parts. We have the two dwelling units, smaller dwelling units on facing the northern facade, and two bigger dwelling units of shipping containers again on the southern side, with toilet and the cantilevered spaces on either side, so that the movement is facilitated quite nicely, and the views of the same have been shown accordingly at the side. This is the gathering space on the northern facade. As you can see, this is an artistic impression again. Coming to the fourth floor, we have the dining area for resilience during resilience, where people can actually have spaces for dining, and as to accommodate that, we have the pantry just aside and a secondary lift which is running from the office from the canteen, pardon me, and up to the fourth level, and with the sit out space at the side which acts as a breather for people directly moving into the structure. Post that, we have an outdoor space for library, which again has a staircase in the middle. The two ends of the library are again, as you can see with the views, and are of again shipping containers. The staircase in the middle will lead to the second part of the library, which is at the floor above on the fifth level, and a storage space for placing other beds in case if there is an emergency. The lobbies can be used for spacing beds or for dining area as well. Coming to the fifth floor plan, we again here have again the division into dwelling units and the library, with three atriums dividing the space quite aptly and quite luxuriously. On the section which we have at the side, this shows again the wind movement through the voids, through the central atrium and through the other courtyards, showing the successful wind movement throughout the site here. So now coming to the normal functioning of our structure. So during normal days, we have the best office and cafe on the first and the second floor, along with the services, followed by clinic on the southern facing the southern facade on the second floor, the library on the fourth and fifth floor facing the southern facade again, and the rest of the spaces have been used as a community gathering space or learning spaces throughout the day and during normal days. As well as during resilience, we have the clinic and ward occupying the entire second floor. The dwelling units again occupying the third and the fourth floor. Some parts of third and fourth were shown. We have the library, which again retains the initial position, and the community gathering space. So if you can see now, the space being modular actually enables us to actually expand and move into spaces, so that it can be given more priority can be given to much more emergency needed functions. as compared to a resilient performance of our structure, we have incorporated certain strategies that include an elevated plinth level to avoid waterlogging. Since Kovali Kolivada is quite close to to the sea, there is a chance it's not usually flooded, but there is a chance in future it might have. So an observation regarding that. An extended mid landing to actually enable much more smoother circulation on the staircases, cross bracing across the entire structure to overcome the seismic loads, the wind loads. And this is a backup option which we had as a electrical buses which the BMC has actually issued during, and it will be running in due course of time. So their batteries can be used as an additional backup in disaster times. Air moisture seal for each and every window frame so that the interior optimum temperature is maintained, and a water resistant container, which again solves the problem of seepage and other parts. So as a backup resource, we intend to provide the project we hand will be approximately of 250 users, and during resilience, 50% of the required energy can be generated renewably, and 100% of water can be stored or conserved via rainwater techniques, which will be further demonstrated. And finally, the urban terrace gardens as a part of recovery. So post the disasters, we have these spaces for recreation and a workshop learning spaces in order to actually educate people as to how disaster management can be applied in their day-to-day lives. Yeah.
As cotton steel being the material of the containers, provides with various advantages of high steel strength, natural oxidation that forms a protective coat and prevents rusting, low maintenance, reduced cost for economies of weight, and 100% recyclability. Steel has a high resistance to lateral load as compared to RCC structures. However, steel containers are already made to withstand extreme conditions, and therefore it can easily withstand the lateral loads of earthquakes and cyclones. Next. The principle that we're using for earthquake resilient buildings is simple, that is ABCD. Next. A, that is anchorage of foundation, bracing of modules, connections of structural members, and single diaphragm as roof. Next. Containers are connected with isocasting as corner to other containers with help of vertical and horizontal twist lock. Further stacking of the containers are done in the same manner. To provide further structural stability, single cross bracing and double cross bracing has been used. Next. The soil of the site after analyzing was found to be sandy. Therefore, micropile system has been used to increase the surface area of the foundation and provide a better anchorage of the structure to the ground. Next. Also, we have designed a customized staircase module with ISMB 100 and ISLC 100, which in order to continue the fashion of modularity. The connections of structural members, such as of slab to corner casting detail, are done by welding them with the MS plate, as it has, as per to Instag standards, it has a higher resistance towards earthquake lateral loads. The bracing is also comprises of lashing rod and a turnbuckle, which has the flexibility of length variety and can be used on both the shorter and larger surfaces of the container. Next.
Yeah. So when it comes to thermal comfort in shipping containers, insulation is the most important factor. Different insulation materials were studied considering different parameters. Of that, polyurethane foam insulation was selected with maximum R value and minimum thermal lag. Yeah. Second diagram of the insulation shows that while designing, appropriate thicknesses of insulation were taken as per required, as different in floor, roofs, and walls. Next. For designing windows, ventilation rates were calculated according to different functions, taking as one of the parameters along with different parameters such as height, opening, flow rate, pressure coefficient, area of the window. Opening areas of the window were decided for stack flow, ventilation, as shown. And for modular approach, opening size with operable effective opening was selected and was multiplied as per the calculations. Yeah, next. For biaxial-driven flow, which was required in some spaces like clinic, where cross-flow is not appropriate to use, window sizes were calculated using Lecaver design guide. Yeah, next. Yeah. So now, dealing with the southern facade, the radiation of the floors, the amount of daylight, and minimum surface area of the material used were put as parameters for optimization of fins. From 572 solutions, the best orientation of the louver was selected, and which resulted into 10% reduction in total floor radiation. The openings in louver were designed with the principle that the radius of opening is inversely proportional to the surface radiation. Next. The louvers are coated with high SRI Titan Cat photocatalytic paint. With titanium dioxide being a constituent, it reacts with carbonaceous constituent and under UV radiation to form water and carbon dioxide as a byproduct. The vertical plantation of English ivy between the louvers make the facade a biowall and acts as air filter and also as dehumidifier. Usage of water and carbon dioxide produced in the previous reactions make the facade self-sufficient and functional. Yeah, next. Hence, with its various passive strategies, the thermal comfort band was broadened to 5,000 hours of thermal comfort. To achieve thermal comfort for remaining hours, desiccant cooling system was introduced. Next. So desiccant cooling system is basically a combination of dehumidification and evaporative cooling techniques. The process is as follows. The dehumidifier removes the moisture from the warm and humid air by passing through the desiccant veil. Mass transfer takes place as heat is liberated during the condensation of water, and after dehumidification, the air is introduced in the evaporative cooler to cool down the outlet air. Next. So this system improved air quality with less electrical consumption and less sustainable and using sustainable refrigerants and low operational cost. And with that, the set points calculated using IMAC Assistant. Next. With that, yeah, okay. So the design achieves 3 lead credits of daylight availability with 90% of spaces, at least 300 lux for 50% of time. Only 3.8% of the spaces receives direct sunlight radiation more than 1000 lux. Figures at the right shows the daylight autonomy and the direct sun radiation for second floor gathering spaces. Next. By using various ECMs, the API was brought down from 86.4 kilowatt hours per meter square per year to 39.94 kilowatt hours per meter square per year. Out of that, cooling lights and equipment has the major load. Next. So yeah, why not solar? As shown in the shading diagrams, site receives sunlight only for average 5 hours a day or even less than that. And the batteries remain uncharged for even more than 99% of the times. So this estimates show that the solar is not very efficient solution to be used in context of Mumbai. So next. Whereas Mumbai has average wind speeds of 3 meters per second, which gives us opportunity of using wind turbines. The wind tunnel formed between the buildings also increases the wind speed, which meets the cutoff wind speeds required for the turbines, that is 2 meters per second. Wind turbines, when compared to solar PV, gives double RE generation and half cost as that of solar, and produce 17,520 kilowatts hour power per year per meter square. Yeah, next. So for that, we are using Avatar 1 wind turbines, which have been used in this design, and they can withstand 250 meters per second of wind speed in extreme weather conditions. It leaves surrounding with less vibrations, and it only needs 1/3 of space as that of solar, which is a benefit in context of Mumbai where less space is available. Yeah, next. Even after using wind turbines for RE generation, we were unable to achieve net zero energy performance. And in the dense context of Mumbai, it is very difficult to for a high-rise, mid-rise to achieve a net zero condition. So for that, we introduce a symbiotic net zero relationship, which can come in play. And in that, the efficiency of first building can be corrected by reducing the storage capacity load of others. So for this, in this example, considering Yeah, next. Considering a case of deficient shelter A and efficient shelter B, where the surplus energy from the efficient shelter B will be transferred from through P2P blockchain platform to shelter A. Yeah, and next. In future, with advancement of technology, this platform can have decentralized distribution of energy in between all the nodes of networks. Yeah, next. Also, after breaking down the embodied energy, we came to the sum of 1,84,1847 joules, megajoules, which is compared to the conventional RCC structure is less than 59.4%, hence making it environmental. Hence, the use of shipping containers is environmental friendly. Yeah, next.
So Vihan has the aim of having net zero efficiency not only during times of disaster but also during normal times. So the structure during normal times has a maximum of 150 users, and the functions for which water has been provided is drinking, cooking, and sanitation purposes along with cleaning. As it's a community center, the usage of the water is not at a higher level compared to it during resilient time. More amount of water will be required as more number of people will be present. The water which is collected from the back. The water which is collected from the terrace catchment areas and the groundwater runoff are both filtered to their respective filtered system and stored in the UGT. The water stored during the normal times also will be used for flushing during the resilient times. Water which is used for white water in domestic usage can be treated with the eco STP which has been provided, and then stored in a separate UGT for grey water and a separate UGT for OST, which will then be flushed out for as black water into the government sewer system. Next. I have explained this next. So considering the Eco STP was a zero energy cleaning system which requires no motors, and it was divided into 4 parts, 4 stages. Each stage clears physical, chemical, and biological impurities from the system and gives pure water, which is not potable but can be used for alternate functions like cleaning, washing, irrigation, and to also recharge the groundwater if required. Next.
According to UNDP, Mumbai has a shelter infrastructure index of 0.5 out of 3, where India has an index of 0.8 out of 3. With 15 different disasters identified by UNDP, having a single solution to all would be ideal. However, having such a huge socio-cultural diversity in our country makes it a continental task. Next, our design being module is flexible enough to adapt to different climatic and topographical conditions with various stacking strategies as per to wind-based and sun-based. According to the terrain type, we can also provide different solutions as per to the shown diagram. Next. Having a modular system or design is capable of completing the whole structure in 5 weeks, which is a large reduction of about 75% of construction time as compared to a conventional concrete structure. Next. According to minimum wages of labor in Mumbai, we can save According to minimum wages of labor in India, we can save a minimum amount of 5.4 lakhs. That is 70% less in comparison with the conventional structure of RCC. Next. Due to the unfortunate incident of COVID-19, India has decided to start manufacture their own shipping containers and stop imports from China, which was sold at a rate of 100 to 150% more than original cost. Therefore, with advent in time, the cost of reused containers will reduce by 45% by 2030, and hence making it more affordable with time. Next. We took a step ahead and designed a disaster management app for BMC. The front-end user has a minimal design which gives an early warning system, which gives an early warning alert to the users. The app is next.
Team Stellar, I'll
app is
need to
backed.
stop you there. I'll just need to stop you there because your time is up. And yeah, so can we have the jury impressions?
Sorry for these are just the 2 slides. Wait a minute.
Okay. Yeah. So Venkatesh, I'll start with you. What did you think about the team's presentation?
Excellent job, Team Stellar and your project, Vihan. It's very comprehensively done. The choice of disaster for Mumbai was quite appropriate, and use of containers is kind of a really um, novel idea to be able to reuse those containers that are not used for shipping. Uh, we see them everywhere in our sites. Those are our standard site offices, but to be able to use them as a resilience day uh, mechanism to live in is also something quite innovative. Few observations, right? From your presentation that was sent to us and what I saw now, the lures, do they come on the north or on the south? Because for some reason, when I was looking at your documentation, I thought the lures were coming on the north.
South, sir. They come on south.
Yeah, because if you can just show the plan, most of the south is actually closed with rooms, right? So are these lures then protecting the rooms, or is it like those open spaces? Like on the ground floor, you have open
So
space.
yes, sir. So on the G+2 and the third floor, the luvers are basically to provide these public spaces. These spaces are open to common public spaces and
Yeah,
clinic and wards and so.
just run your mouse where the south is, because that looks like a full container in itself, right on the south. Yeah. So the lures then come outside this,
Yes, sir.
outside the end of the
Outside,
container.
yes, sir.
Okay. So for some reason from the renderings it looked almost like it was coming in the north because you had those large openings. So I could be wrong in that. That is fine. The other question that I had, which didn't come out very clearly in the documentation, but which you explained quite nicely here, is the use of the desiccant cooling, which I kind of assume is like the recycling of energy from return air, right? Is
Yes,
that
sir.
in the air-conditioned areas that you're using it for? And can you just clarify
Yes,
which are those air-conditioned areas that you are looking at once again?
Yes, sir.
Madhav, would you like
I'll
to
take
take that?
Yeah. Yeah, so basically, sir, if you can see, majority of the plans which have been there, for example, the canteen spaces, the residence office, the clinics, and the smaller units, the dwelling units, and the major dwelling units. These are the spaces which will use this technology. It was again mentioned in our appendix as well. So these will be spaces will be basically the places where more people will be residing rather than gathering. So at that spaces, we were thinking that these strategies can be used on all of the floors, set out storage, library. Yeah. So all of these containers which are placed on, which are most
Yeah,
probably same,
because one of the
will
things
be.
that came to my mind was that if you could avoid it, that little bit of air conditioning also, then your energy performance would have been even better. Because I really didn't think that you needed air conditioning for this kind of a use, this kind of a building type. Again, one thing which didn't come out nicely in your documentation, but which you explained here, was the use of blockchain technology for using energy. It could be positive somewhere
Yes,
else,
sir.
negative in some other location.
Yes, sir.
I'm sorry if I didn't catch it in the documentation, but that's kind of come out nicely here. I wish it had come out as clearly as you explained here in the documentation that you had submitted. But that's again kind of really innovative use of technology, because it could be positive somewhere, it could be negative somewhere, and overall in the scheme of things,
Yes, sir.
this balances out. My last observation, I mean, two observations which I find that you probably have missed out. One is, uh, even though you have restricted sunlight on the site, I just wonder if you could have made use of solar heating for some of the hot water requirements that you would have in a place like this. So that is something that I found missing. Solar PV, yes. Use of wind as an alternative to sun. It's a nice twist to the tail, but with all the heat that just gets wasted, I was just wondering why couldn't you have had like some solar collectors for hot water? And the last point, which I kind of find again a little, I mean, I won't hold it against you. Okay, you guys have done a fantastic job. So let me first give you kudos for a great job. Is water. The biggest problem in a on a disaster day is availability of fresh water. And looking at the number of people that you have in this building on a disaster day, I just wonder whether your capacity for the overhead tank is sufficient for 2 or 3 days of continuous use, because that's the time that when your underground sumps are contaminated, you need to kind of flush them out, put new water in there, treat it, and then be using water for drinking, cooking, etc., etc. So that was about the only thing that I could find fault with you guys. But fault is a word that I use kind of lightly. You guys have done a really good job. It's something you should be very, very proud of. Congratulations for a job well done. Excellent.
Thank you, sir.
Thanks, Venkatesh.
Thank you, sir.
Thank you, sir.
Vinay, could we have your comments?
Sure. Yeah, first of all, I think like Venkatesh said, very nice job. I think very clean present. Your presentation was very nice. I think there were elements of it which were not very clear in the report, which came out quite nicely in your presentation. So good job. I just have one question, and I'm interested more in trying to understand how you would how you would react to this question. I'm just curious to see how you would think about it. So let's assume that I'm a builder or a developer of some sort, and I say, okay, I want to implement your technology, but then I want to do it in half the time that you're proposing currently. Okay, I want to speed it up even bit more, because the value that you're putting in really is the modularization and being able to quickly stack it up. But then I want to ramp that up even further. What would be some ideas to do this even further? So you can just to also give you there is no right or wrong answer. I want to know how you think in the design stage. What would you do in the preparation side? What you would do, so that on site the preparation time is reduced by 50%.
I'll take that. Manav, could you please share the presentation? It's not being presented. So we can look over some overlapping areas since we have modularity as a concept. So the you can say the finishing part of the module does not have to be done while it is on the site. So the foundation part and the construction of the module and its internal installations and stuff can be done parallelly, and then at the time of after the construction of the foundation, and when it's a buildable stage to stack the containers, it can be then used. Obviously, we can use a little more labor force. Currently, we have considered by an approximately rate of having approximately 20 to 25 people working on the containers and the foundation system simultaneously. So I guess the overlapping of the functions because of the modularity and increase in labor force.
I would like to add to that. So basically, again, as Manan rightly said, the labor force and other things are a very important factor. But since this is being a community space where multiple stakeholders are being part of it, it would be quite nice as to, since this Kolivada area does not have a specific library zone provided for them. There are schools, of course, there are schools, there are clinics, but they are not specifically provided, which is coming at the center. So this is, as a holistic approach, it's very good to actually take everyone together and move ahead, so that again the community interest will again push this idea much more ahead. That's what I think. Actually, we all believe that could be a part of it. So building is such a design such that it is respecting each and every stakeholder in it.
I would like to add, if instead of using furniture which we have added externally, maybe if they could be used prefix furnitures which are already made and can be added into the fixtures. And also, when we visited our project partner, he had constructed a small mobile home out of a shipping container, which he wanted to transfer to whichever site he wanted to. So if this could be done at a mass production scale with fixtures which are mass produced, the whole process would run a bit faster, according to me.
Okay, thank you.
Sounds good.
Thanks,
Thank you.
Aditya. Yeah. And Anamika, lastly, your comments?
Yeah, Venkatesh and Vinay, you summarized it very well for the team. First of all, congratulations. You've done an outstanding job of, I would say, imbibing the spirit of this competition, which, stems from innovation. And your the basic premise of the container, it's an innovative solution. It addresses, replicability, modularity, affordability, and speed as well. So I think you have really, arrived upon a very um, apt model here that can actually be used as as an example for the rest of the country as well. There's always a, but, so my
But
only concerns were, I think that the distinctive architecture that, this the use of containers, you I feel that you did not exploit it enough. In your drawings, but fortunately, when I saw your presentation, it's actually addressed that aspect very well, and your drawings and presentations have come out very well. Um, and there's a distinct improvement between the documents that you had submitted and what we got to see today. So, all good. I was just wondering if you came across this at all. That is it a challenge to is the assembly a challenge under constrained spaces, especially like those of Mumbai?
um, yeah, as far as steel containers are concerned, um, however, as I mentioned in the presentation also that due to the COVID, India is starting their own manufacturing of steel containers, and therefore they are starting 10 new centers for this production all over the country. So this sort of expands the network of availability of steel containers in all over the country. And as far as your question comes, the the transportation of the steel containers to the site is a bit of an issue, but
Yeah.
it can be managed with proper invigilating services, and things can be looked after for the furniture inside, and so
Yeah, I speak from experience here. I've used a container for one of my architecture projects, and it just came up at the last minute that, the kind of turning radius and the kind of space around the site that you need to assemble this, it can pose a challenge. But I'm sure it won't be a challenge for your innovative team.
yeah.
So
As a
thanks,
site is a
Anamika.
bus. Sorry.
Yeah. So thanks, Anamika. I think we got a comments from our jury members, and so very interesting presentation, Team Stellar. So thanks for your presentation, and let's take 5 minutes, and we'll quickly go on to the next presentation.
Thank you.
Thank you.
Thank you for your
Thank
time.
you.
Thank
Thank
Good
you.
luck.
you.
Good luck, guys.
Thank you.
Hi.
So, hi. So our next presentation is from Team Nbil, and they have worked on on Project Drit in Kambalakad, Kerala. Their project partner is Sustainable Environment and Ecological Development Society. So can we just do a quick AV check with you guys? Um, so, hi Asta, can you hear me?
Yes, I can hear you.
Yeah. Sandeep, could you just do a quick AV check?
Yes, hello.
Yeah, great. Chaitanya?
Yeah, no, I hope I'm audible.
Yeah,
Hello.
great. Yeah.
Okay.
Vidushi?
Yes, hello, good morning.
Yeah, great. And I think we also have our project partner, Mr. Manu Gupta. Hi, sir.
Hi.
Yeah. So team, please share your screen and can you go into slideshow mode?
Yes.
So all the best to the team.
Thank you,
Thanks,
sir.
sir.
Thank you, sir.
I hope the screen is visible.
Not yet. Yeah, it is now.
Okay, just let us know when we can start.
Yeah, so you'll have 25 minutes for your presentation to the jury. At 20 minutes, I'll ring a signal like this. Could you hear that?
Yes, sir.
Yes.
Okay. So you won't have a 26th minute, which means at 25 minutes, I'll need to stop you and end your presentation. After that, we'll have a 15-minute Q&A session with the jury and the project partner. And yeah, so all the best, team Nilbil, and the stage is yours.
So, good morning to everyone. We are Team Nbil, and our project is Project Trip. Just about us, we are a team of 12 students, mainly from School of Planning and Architecture, Delhi, as well as IIST in Delhi School. And our project partner is Seeds, who has worked in building the resilience for the people who are exposed to these disasters. So they are really participatory driven, and they have a lot of projects which have been implemented on ground. Coming to our project, what is Project Thread? So when we understood the effect of disasters, of how disasters occur, there are numerous places that face disasters, numerous stresses and shocks, and there is certain sort of response that is expected from authorities. Usually what happens is we don't have dedicated infrastructure for this. And at times of these times, well, schools are what rise up to the challenge of actually acting as these resilient shelters who cater to the people who are affected by these disasters. And this is especially true in villages. So that is what we are trying to do in our project of creating a community resilient shelters in schools, hence being the multipurpose nature of it. Now, our site is located in hot and humid climate zone of Kerala. It faces a tropical monsoon climate, and it is in the Wayanad district of Kerala. So, Kambalakkar, as you can see on the site, it's an already existing school, but the site gets flooded. However, what we know of this site is it is at a higher elevation from all the surrounding areas. So, though the surrounding areas get flooded, this site remains above the elevation. And so the school which is here, there is a government primary school, already functions as a CRS but is not equipped to handle it. And the government is looking for rebuilding the school. So what we are going to do is a completely brownfield development of this site. So there won't be anything regarding the school, existing school here. Wayanad district faces two critical natural hazards, which are the floods and the strong winds. So I already said that it faces floods yearly. As well as along with that, what we have are the strong winds that which occur with the floods as well, and which leads to the trees falling down, the electric poles falling down, which causes severe disruptions in service delivery. Another aspect which is local here is the the Kambalakkad village. It is part of a bigger village, Kalimbetta. It has marginalized community with people who are socioeconomically poor, and they don't have as many resources as well. So we had to understand this dynamics of the demography there. Now, coming to the site, we did a climate analysis, the sun part diagram, the ventilation, and all those things. And we as well looked at how it functions as both the school and community resilient shelter. So it works from 9:30 to 4:30. However, during the monsoon period, peak monsoon usually lies between the July and September. What we have that during this time when monsoon hits, around 10, 15, 20 days, the people come here due to the people who are hit by the flood struck areas. So from the evidence from the talks that we have, we know that around 200 people come here for community resilience during disasters time, and it caters to around 400 students plus 50 staff. But it is from class from nursery to class 8th. So this is about the school. What were the requirements that we wanted with this project? First, it had to be net zero energy and water building. Our project partner had put us that we had to produce at least 90% energy from solar. We had to follow all the guidelines of NDMA of the building bylaws, and we had to withstand floods, high winds, as well as earthquakes, though it is not a major hazard in that area. Apart from that, after analyzing the local context, what we as well got to know that it had to be simple because people are not that literate. So we had to make it very simple and very intuitive. It had to be community centric if it has to be a community resilient shelter. We had to have at least 2 day complete autonomous, as I said, due to those issues of high winds. And we cannot use HVAC system. That's a big thing because it is a village. You cannot expect, it does not fit in the context at all. So we had these sort of requirements that we had built up for ourselves. So now coming to what our design is, I hand over to Asta.
Yes. Moving on to architectural design and spatial understanding. The design was thought of considering the local community, the climate, and the spatial considerations required for a school and a CRS building. Next, please. The site has one access road to the south, which is 1 meter below the site, which has been retained, and an entry has been provided from there with an adequate ramp of 1:10. Since the site lies in hot and humid climate, 3 blocks were divided based on use: admin, classrooms, and kitchen dining area, and then combined in a narrow linear form with a singly loaded corridor to achieve maximum ventilation. These blocks were disconnected yet connected so as to allow for easy access during use as a CRS. Moreover, the need for a large open space for use uh, during times of a disaster as well as for school hours also dictated the form to be as it is right now. The long corridor, the major active zone with the classroom that you see on the northern side, has been designed facing north-south, like predominantly north-south, to protect from harsh suns. Services such as STP, rainwater tank, etc. have been provided according to the natural contours, and some have been provided close to the main access road so as to provide ease in connection with municipal lines. Next, please. The slide's not changed, Chaitanya. So the design is flexible and caters to spaces in a school as well as a CRS. The graphic shows spaces in a building and how their use will change in course of use in times of a disaster, which I'll explain in detail through plans. You can go on to the next slide. Next slide. Ground floor plans and use of spaces during school hours and during use as in times of a disaster. So the classrooms that you see will be used by the affected people, and the people from the same neighborhood or the same locality may be accommodated together for a sense of belonging and security in times of disaster, with storage space for important documents, essentials, taking up the space of cupboards through the recesses that have been provided. Medical services close to the admin for ease and coordination during use as a school as well as a CRS. The multipurpose room that you see in pink will function as a recovery room and is in proximity to the sick room, which will be used at times of a school as well. During use as a CRS, the admin will be shut and the staff room will function as authority, store and management for the people actually facilitating the rehabilitation and the relief process. Additional storages have been provided close to stairs on each floor. You can move on to the next slide. Next slide. Yeah. So similarly, on the first floor, certain classrooms have been closed, certain rooms have been closed down, which include the labs, the science lab, library, because they contain important document as well as certain things which should not be accessed by the populace. And the other classrooms have been converted into living area dorms. Next. Next, yeah. So the kitchen has been kept away from the prevailing wind direction and also away from children so as to prevent distraction during class hours. Also in a corner to facilitate loading and unloading through the setback, which will serve as a service corridor. Small children, that is the KG nursery kids, are designated on the lower floors and a separate play area has been provided for them at the back. Spaces that do not need use during CRS hours, like the labs, are on the first floor and not on the ground floor. Also, buffer area has been provided on the roof for emergency supplies for sudden upsurge of people during a disaster, and has been provided with an adequate slope and waterproofing to drain out rainwater to ensure safety. You can move on to the next slide. Next slide. Yeah. So accessibility, ramps have been provided with a slope of 1:12 as per harmonized guidelines where people actually have to walk through completely. Since there are no lifts, the ground floor is equipped to cater to all user groups with facilities such as accessible washrooms, ramps, grab bars, etc. Moreover, since cattle is a very important part of the lifestyle of people in Kambalakad, space has been provided to accommodate cattle. Sandeep, you can continue.
Yes. Next slide. Yes, so resilience being the most important part of the community resilience shelter. So we have taken a lot of strategies to make the building a resilient one. So as we know, the site is above at a higher altitude than the surrounding areas. In addition to that, there is also 1 meter elevation from the road level, which provides enough elevation for a future flood level, for a future high level flood. While we have also raised the plinth to 1.5 meter, which is another additional advantage we get from the flood. While the open terraces act as a rescue zone for the to allow for the air evacuation during the disaster times, and also we have also provided a shaded region below the solar PV, which acts as a surplus area for the people that come during the disaster. If there are any surplus people, they can be accommodated inside it. While the RCC frame structure was necessary to make the building a resilient one, since there are a lot of chances with the increasing climate change of many disastrous cyclones and tsunamis, etc. While the corners have been minimized, have been rounded in order to minimize the impact of high winds, which are very much higher in these regions. While the covered car parking are used to shelter the cows and the many various other cattle during the disaster times, as they form the part of the major part of the livelihood of the residents there. Next slide, please. Yes, so going through the planning, how the people will be acting during the pre-disaster times. So the building will be acting as a CRS for about 20 days, which is during the monsoon period when there is a lot of rain, which causes a flash flood and uh, destroys the major part of the villages. While the capacity building has to be done in order to educate the people about the emergency planning that they will be taking account into while going through the disaster. As well, the area is majorly populated by the Muslim community, so there are a lot of madrasas and mosques which can be used to alarm the public about the incoming disasters through the mics and all. While there, as the most of the floor spaces shown earlier overlaps both in terms of during the school times as well as CRS. So a rapid transformations can be done during the CRS time, and the people can be saved very much fastly. While we also see this is a government school, so there is a midday meal kind of thing happening here. So already there is a lot of essential commodities can be stored here, which will be helpful during the disaster times. While also medical care center is provided to take care of the medical facilities at the time of disaster. And here we can see how the chart, how a school will be converted, what will be the procedure or the operating procedure we will be taking through. So the major of the rooms which will be containing the fragile equipment such as computers and all will be closed down and can be used to accommodate uh, major as a storage areas, while the benches that are designed innovatively can be stacked together and they takes a very less space, since the benches are taking a lot of spaces in a classroom. And also the people of the same community will be moved into a single room, which help them in coping with the disasters stress during the disaster time. Next slide. Next slide, please. Next slide.
Sir, I think there is some internet issue. I hope it will be considered.
So do you want to quickly share your screen?
Yes, I'll share my screen.
Yeah.
Just a minute. Is the screen visible?
Yeah. Yeah. Continue, team.
Okay. Okay, so as Sandeep talked about resilience, this is the basic way in which our building will function during disaster. Coming to the next contest, which is comfort and environmental quality. So for occupant comfort, we have considered the IMAC thermal comfort standard, and since we have a rural Kerala population which we are catering to, we have increased the thermal comfort standard range from 27 to 32 degrees to 27 to 34 degrees. The indoor comfort that we have achieved without air conditioning is 80% according to the IMAC Indian model, and the annual comfort hours that these are the simulations that we've done from Design Builder, and from them we got the basic indoor comfort hours according to ASHRAE, and then we converted them to IMAX. So since our building is unconditioned, we have 80% indoor comfort, and we have also tried to achieve it further through the other strategies which are mentioned here. The fenestration that we have, which are majorly the windows, are louvered, so they are shaded from direct sunlight. The windows that we have are Saint Gobain single panel windows, which helps in reducing the glazing, which helps in reducing and improving the in envelope quality. The indoor air quality that we have is improved because of the cross ventilation that we have tried to induce. As we can see in the plan, whichever windows we have provided are facing each other, so we have induced cross ventilation, which is very important in our climate, to reduce humidity and induce freshness inside the spaces of the building. For thermal and visual comfort, we have tried to give larger windows, which do not, and as well as a singly loaded corridor, as described earlier. So the amount of daylight which enters inside the building is sufficient, whereas the glare, while avoiding glare as well. The landscape elements are very important on site because since most of the trees were already existing on site, so mature gulmohar and mahogany trees existing on site we have tried to preserve, and then we've also added some other trees away from the building towards the north side, which is the main prevailing wind direction, so that cooler winds come inside the main classroom areas. And help in cooling down the building further. The energy performance, for the energy performance, the initial API that we had achieved was 111. We narrowed it down and came down to 70.6 kilowatt hour per meter square per year, which is lesser than the Griha benchmark of 82 kilowatt hour per meter square per year, but still a little more than the goal that Decathlon gave us. The main according to the main initial benchmark simulation that we done, we have a 14.6% reduction. Again, this reduction is mainly due to ventilation, lighting, internal lighting, cooling, and equipments. The main renewable energy system. For our building, we have tried to use renewable energy mostly as solar energy. The building has 250 square meter area in which solar panels are fixed. We have also incorporated vegetative creepers to increase the shaded area, which comes under the solar panels. So the solar panel structure that we have used is a raised structure, and it helps in it on the rooftop, and it is also placed on the area which is away from trees as well as away from most mub trees, and so has maximum sun hours present on it. The building can run off grid for 48 hours, which is the maximum time for in case of a lockdown or in case of a very intense disaster. um, for 48 hours, the building can run on a battery. The system that we have used has monocrystalline solar panels, and the the system, the further other elements that we have used are a hybrid inverter and lithium ion batteries. So the hybrid inverter ensures that during the time the school is not off grid, when it is on grid, it is being the inverter and the batteries are being used, which is why it won't go. The battery will still work later on. Sandeep will talk about the engineering design quickly.
Yes, talking about the engineering and design, since we did not have any HVAC system, higher HVAC system, so we prefer the single phase power connection. While the RCC structure has been designed according to the limit state method, and also we have provided isolated pad footings which are required in this region due to the shallow hard strata found here, and also expansion joints are given so that all these blocks act isolated and to accommodate the expansion and contraction during the summer and winter times, and also the surge protections during the as the place is there are a lot of thunderstorms coming in this place, so a surge protection kind of lightning conductors have been given so that the most of the appliances did not get damaged. And here are some of the things we have also provided for the filler slabs so that they can be effective in reducing the amount of material, as well as adequate amount of reinforcement covers have been provided to reduce the corrosion of the reinforcement in the building, while the whole structure has been designed according to 500 kg per meter square. Yes, now coming to the water performance, the Kerala receives the first showers of the monsoon. So there are a lot of ample amount of water that can be tapped through the rainwater. So we have provided 30,000 liters of underground water tank that can be used to collect these rainwaters through a bio sand water filter, and these can be used during the CRS times, while the municipal water can be tapped during the winter times again. And biosoils also provide for the rapid percolation of water. Next slide. Yes, so here we can see the biosand filter that we talked about is about 75% of efficiency, so it provides a lot of water, and also the daily consumption of water is around 15,000 liters. So these can be managed through the overall tank capacity, and also double stack system is used to facilitate the reuse of grey water in the system. Next slide. Yes, coming to the affordability, the capital budget set by our industry partner was around 2 crore and 56 lakhs, but by efficient use of spaces and reducing the circulation spaces, we came down to 2 crore and 29 lakhs. And again, applying some of the best strategies such as locally sourced CSCB blocks can be used, which again makes it much more affordable and reduce, and Mangalore tiles and interlocking CSCB blocks, and avoidance of any HVAC system as the comfortability can be naturally maintained. So the much more affordability came in around to 1,72,000. While here we can see in the chart how this is very much efficient than the baseline estimate. And also we have taken it into the operational energy. Next.
I hope I'm still good. So, regarding the innovation, we had three main issues. First was we had to ensure that there was a maximum utilization of space. We don't have any empty spaces because if it is multi-purpose, we had to ensure that most of the space gets utilized. We don't want to create two buildings. And you will see from the zoning diagram that we had especially incorporated in area-wise, it was approx 90% of the area which was getting in both use. Again, managing these people, as I told about socially backward, how we can group them from locality wise to a particular room so that they feel safe together, they can connect with each other. Then having those cattle shades and using local arts and paintings for walls, these all help managing the people during the resilient shelter. And third, which was major issue, which Sandeep as well had mentioned, was the lack of space due to benches. And this is why we actually designed our own modular bench. This is one of the biggest part of this CRS conversion, because in the school this was the big issue. So what we did, you'll see that this bench seems simple because we have incorporated very simple design ideas. You don't need to put it just as it is, but there are a few principles that you need to do. So the back sit with the backrest which is there, it actually gets interlocked with the table ahead. So there is a cavity within the front two pillars, so they get interlocked, and then you can have 6 of these benches together, and it can even form as bed in terms of emergency or during night.
Yeah. So, team, I have to stop you there. So, uh, so
Yes, we
let's.
just had 2 more slides, and yeah, that's fine.
Yeah. Yeah. Okay. So let's just quickly move on to the jury, and let's hear what they have to say. So I think I'll start with Anamika. Can you, what did you think of Nilbil's presentation?
Hi everyone, congratulations on reaching here. It's a huge achievement, and your design shows why you're here. I think you've paid a lot of attention to, framing the context. You've done that very well. Address the core issues of disaster planning, given kind of occupancy you're addressing. Address the basic issue of rapid transformation during disaster time and planning for disaster very well. Your comfort and environmental strategy has also been thought through very well. I think I missed an important point, which is what is your EPI?
We've achieved 70.6 kilowatt hour per meter square.
So, considering this is an unconditioned building, I think you could have gone for a more ambitious, a more aggressive shaving of your energy loads. And one other observation that I have is, did you consider your, specific location or local materials? Like, did you consider them and discard them, or did you find them not practical or replicable or scalable enough? Was there any thought accorded to this? Again, it's not a criticism at all. I'm just having a conversation.
Ma'am, actually, we gone through the various guidelines that was provided for the cyclone and various other shelters that are built in India. So it really thought about making a building much more resilient. We had to go through the RCC framework. That's why we have adopted that itself, and putting in the some of the natural means local materials. We have used means filler slab kind of thing that is very much common in the Kerala. So through the Mangalore tiles, we can use that. We have used that.
Okay.
Right. So from a structural perspective.
Yes, on the structural perspective itself, we have chosen that.
Fair enough.
Okay. So I'll just quickly move to Venkatesh. What did you think about Nilbil's presentation?
Nbil team, you guys need to smile a little more and be a little more comfortable. We are friends out here. You guys seem too tense. We're not here to chop your heads. So relax a little more. Let me see some teeth. Okay. Um, okay. A good job. I had a doubt when I saw your presentation first on whether you were repurposing an old school or doing a new construction. But today I understood from your presentation that you are doing a new construction. Okay. One of the things that I mean, this is something that I'm just telling you as what you guys should keep in mind going forward. First of all, you've done a good job. I like the fact that you look at no air conditioning and all those things, and keep the baseline energy itself quite low so that you can achieve your targets quite easily. Choice of Wayanad is also great because Wayanad and Coorg. Um, I think Vinay and me are the only two guys here from South. So come May and June, we know that either of these two places is going to have a disaster. You know, we love Kurg disaster because it brings water to Tamil Nadu, but we feel bad about Wayanad all the time. One of the things which just caught my eye, okay, this is just like a design point of view, is that we always associate Kerala with sloping roof. You guys have a flat roof. I just kind of wonder, why you did that. I understand that that's extra space that you can use, but typically if you go to any hill station, even Himachal, Kerala, Kurg, anywhere, the gable part of it, the roof is always used for additional storage. So you guys were talking about roof for storage, so that's something that they already live with and do it. So that is something that we should keep as a takeaway from this. I also noticed that you had a room for the livestock. Um, that is also something that you obviously paid attention to. Two things that I kind of find that you missed out is one is with so much of flat roof, I just wonder why you could have even added solar heating to have improved your energy performance and use collectors for hot water and stuff like that, because that's something that you can always use on a normal day for kitchen cooking, etc. And on a disaster day you still get some hot water from the solar collectors. The other thing that I find is that in the schematic drawings you've shown an overhead water tank, but in none of your renders do I see an overhead water tank. So this water especially in a place like Wayanad is, two things happen. A, you have the deluge, and most of the water runs away, and the other water which is left behind often gets contaminated. So it's always helpful to have plus amount of storage on top. It is a structural challenge, yes, no doubt about it, but that's something that also you should take care of. And the attention that you paid to the pillar slabs, and you've done some really good job with keeping the baseline costs quite low. One last pointer, again, these are just kind of lessons, and these are things that even we kind of come across as we look at your work, is that in a place like this, um, even when you bring in livestock and stuff like that, right? People, when they come with a lot of baggage that their essentials, what is important to them. I don't know if it would make sense for you to have stilts, because then that also lets rainwater run away, rather than having to design your walls to retain that kind of force of running water, and elevated the school some more. You have elevated the school up, but which you already done about 1.5 meters. Another 1.5 meters would have given you a nice tilt that you could have used for these secondary storage and accommodation purposes. So that's about the thoughts that I had. Um,
Yeah.
Very nice
So,
job. Your rendering was quite nice. I liked it. Thanks.
yeah. Thanks, Venkatesh and Vinay. Could you also quickly, go give your comments?
Sure. I think, by the way, congratulations to all of you. Nice. I specifically like the fact that you were able to use. There was a certain duality of. So you're using it in school in the morning, and then you're able to use it as a community resilient shelter later. And like Venkat was mentioned, this cattle thing, just keep cattle very quickly. I would like to hear if there are from you guys, any ideas you have on how you could use digital technologies currently to be able to contribute to any ideas that
So, ready?
Yeah, go ahead. Just
Yes, sir. So
one or two
what we had this one was especially regarding to the solar. What we have is that hybrid model of which actually uses both input and output. It uh, works both ways basically. What it does, and it as well has this battery always works. It's not like it's stayed aside.
clear.
So the
Okay.
even AC
Yeah.
that comes in, it goes to that. Now what happens? We can always monitor how much the battery specs are there. Now, especially what we know that during these 2 months of when there is high risk of disasters, what we can is through maybe certain sort of innovation, some sort of app, we can set okay, have minimum 80% stored always. What we did, we have that redundancy of having 2 days complete autonomous. So that is 2 days. The battery storage what we have is, if it is completely full, it will work for 2 days, even if there is no sunlight.
So just
Even
to
if there is no sunlight.
So the reason I asked this was, I think there are several such small things you can come up with,
Yes.
and it also help you address the lower PPI points that Anamik also brought up. So, these small things will really help, and that's what you have done. But good job overall.
Thanks, Vinay. Thanks a lot for your comments. And quickly, can we get some comments from from the team's project partner, Mr. Manu Gupta?
Yes, hi. Let me just get rid of this sound, please. One moment.
Sir, also may I add on the fact that so the 1.5 meter plinth that we have given was a requirement that was given by our project partner, and since we also had a height restriction of around 12.5 meter, we could not exactly go for a stilted. So we also thought of that, and since most of the community residence shelters that we also referred to as case studies also had these stilts, so most of the cattle and most of the storage space could be used as the stilted area. But since we had height restrictions as well as the main brief which had key 1.5 meter plinth we have to give, so that's why we considered that.
And that site was already 1 meter above the road level, so the water rarely came in.
So thanks, Vidushi, for clarifying that. Manu sir, can you kind of really quickly give your comments on the team's
Yeah,
project?
so thank you very much. And I really enjoyed the presentation today by the team, by our young friends here. Just to give you one very short introduction about seeds, we've been in the sector of disaster response reconstruction for now about 25 years. And in Wayanad, after the 2018 floods, we've been working quite extensively doing reconstruction of schools, of Anganwadis, and of course, about 500 houses across the district. And so it was very interesting to see how sensitively the team has actually absorbed some of the local challenges, the local characteristics of Wayanad in their design principles and their approach. I think the challenge of converting existing school buildings into community shelters is actually quite challenging, and it often doesn't happen, honestly, because of not design reasons, but more due to administrative and use reasons. So I don't want to go into the administrative part of it, because these are government structures and they don't want to convert them into community shelters for various reasons. But the bigger point is about the use, and I think what the team has done really is looked at various aspects. And I was kind of making my notes here while they were speaking, and it seemed they've ticked almost all the boxes. And nothing to discount their work, but I must say that use of buildings in disaster times becomes far more complicated than one can imagine. I mean, there are issues about abuse of children, about safety of women, about how the space is used. I think Venkatesh, you mentioned about the belongings that people want to bring with them in these shelters. And then the fact that you've designed for an autonomy of 48 hours, I think it requires more time, because power does take a lot of time to get restored. But those are things that I don't expect you to know at this stage. And so it should not take away any points from what you have scored. But I think going forward, this is a great team here, and I was very impressed. I would take it away and implement it. And the fact that you have helped us reduce the cost by 30% makes it even more attractive as a design. So congratulations to the team. Thank you.
Wow. Nice. So thanks a lot, Team Nbil, for your presentation.
2 extra marks for their name.
Right, yeah. Okay, so Now we will be taking a short break for lunch, and we'll resume our presentations at 1:45 p.m. And Team Alpha is going to be presenting next. So the jury members and the students can join back at just 5 minutes prior to the presentation. So yeah,
You said
let's
145,
see.
is it? Srijit? 145.
Yeah, it's 1:45. Yeah. Yeah. So thank you, and we'll be back after this short break.
We don't have to log out. We can just mute and
You can
log
just
out.
keep the stream running. Yeah.
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 Sujit, remove yourself from mute.
Oh, sorry. So welcome back everyone to the CRS division. So we will now continue with our presentations. Our third presentation is from Team Alpha. They have worked on a project called Beyond Disasters in Pune, and their project partner is Sustainability Initiatives. So let's do a quick AV check. Athav, can you turn on your mic?
Yes, sir.
Yeah. Okay, good. Amrita, could you turn on your mic?
Yes, yes.
Nishad?
Yeah, hi.
Yeah, hi. And Mohan?
Hi.
Yeah, great. So, team, can you quickly share your screen and go into slideshow mode?
Yes, 1 second. Is my screen visible?
Yes. So, team, you'll have 25 minutes to present your work, and at 20 minutes, I'll ring a signal like this. And you won't have a 26th minute, unfortunately, and which means at 25 minutes, I'll need to stop you. And after that, we have a 15-minute question answer session with the jury members. Okay, and so you guys can take the stage. It's all yours. All the best.
Thank you, sir.
Thank you, sir.
Let's start. Shattered, distraught, helpless, vulnerable, alone are mere words. Until a disaster strikes, home is our safe space. But can our cities, our homes, shield us from the wrath of disasters? Hi, I'm Nishad Ghodke, a fourth-year architecture student at the SMEF's BRIC Group of Institutes, Pune. The competition division chosen by our group, Team Alpha, is a community resilient shelter. A community resilient shelter plays a vital role in large-scale disasters and are an essential part of disaster response and recovery. Community resilient shelters provide private and secure places for people to live who have left or lost their usual accommodation due to some form of disasters. They provide immediate and short-term shelter for the victims of a disaster. Still, they also help them recover from the trauma of a disaster and provide a base to start the process of rehabilitation. In this presentation, we will discuss the shortlisting of the site, design evolution, beginning from the zoning and coming to the final form, and how the structure targets the design contests. The city chosen by us to build our community resilient shelter is Pune. Pune is a metropolitan city in the state of Maharashtra. It lies on the western margin of the Deccan Plateau on the leeward side of the Sahyadri mountain ranges. The city is blessed with Mula and Mutha river that originate in the Sahyadri ranges and transverse across Pune. The two rivers further meet, and upon their confluence, the Mula Mutha river is formed, which further drains itself into the Bhima river. In May 2016, Pune was selected among 100 resilient cities worldwide. Pune is an integral member of the leading community of innovators and highly esteemed cities ready to build urban resilience across the globe. Even though Pune has been ranked as the country's most livable city in the new Ease of Living Index, it is hit by disasters frequently. As shown in the timeline, Pune has gone through some extreme shocks, including the 1896 plague, 1961 Panchet dam burst, floods, earthquakes, droughts, and COVID-19 pandemic outbreak in the urban city. So it is crucial for us as a society to concentrate on these problems and build infrastructures that can protect and provide critical services and connect the citizens at this time of such disasters. The earlier settlement of Pune developed near the confluence of the Mula and the Mutha River. But over the years, due to the rising job opportunities, fewer land prices, overconsumption of core city, and cheaper transportation, the city witnessed development in the fringe areas, which as shown in the map over time resulted in the depletion of river and green covers around the city. Some of the factors such as earlier economy, demography, housing, transportation, inner city problems, etc. have led to urban sprawl. The infographics on the right shows us how rapid urbanization, climate change, and disasters are related. Pune city experiences two types of shocks and stresses, which are chronic shocks and acute stresses. Pune grapples with chronic stresses like mobility, health of water bodies, access to affordable housing, air pollution, and solid waste management. This weakens the fabric of the city on day-to-day basis. Pune also experiences acute shocks that threaten the city. The top shocks in Pune include high rainfall, flooding, earthquakes, and disaster outbreaks in the urban city. Different hazard maps of Pune city were studied to choose a suitable location for the resilient shelter.
The seismic map shows us that the Pune city lies very close to a seismically active zone around Koina Dam, about 100 kilometers south of the city, and has been rated in Zone 3 by Indian Meteorological Department. Central Pune is located at the confluence of the Mula and Mutha rivers. These dams store water for Pune. These release water from the dams on occasions and in monsoons when the dam capacity is full. Hence, flooding of Mula and Mutha happens only during heavy monsoons. Elevation of map. Lower elevation areas near the Mula Mutha rivers are more prone to floods as surface water flows from higher to lower elevation. The overall hazards and urban growth map of Pune help us locate minimal disaster risk areas that could become a potential site for a community resilience. Referring to this vulnerability map, dark green color highlights the areas with a meager chance of getting struck by hazards, showing potential sites for the community resilient shelter. The wards affected and threatened are Aund, Gole Road, Varje, Dhole Patil, Sangamwadi, Kasba, and Tilak Road. The low-lying areas are Vithalwadi and Anand Nagar of Tilak Road ward, which is more vulnerable to floods and other disasters. Disasters chosen to tackle were earthquakes, floods, and biodisasters. After analyzing the maps, the ward were compared on the parameters like slum density, earthquake, pandemic, flood risk, etc. From the parameters, the site was narrowed down to 4 locations, including Varje, Karve Road, Yerod, and Hadapsar. These areas were chosen as a potential site and they were least vulnerable to the disaster present in Pune city. Another critical consideration was the distance between the site and emergency service, such as hospitals. This Venn diagram shows how different locations are compared with different aspects like slum population, vulnerability, and total area. The final location selected was an open area adjacent to Karve Road near Karve Nagar. The location is well connected to the city by Karve Road and Vaji Road. The site is also near the ongoing metro project. The Pune is in close vicinity of 4 major hospitals in Pune. The site has an altitude of 535 meter which protects it from floods. The region surrounding the selected location is also vacant, thus the future expansion can be proposed. This site is a north-south facing with an 8-meter wide road on the northern side with a gradual contour and with no trees.
India has been hit with more than 300 natural disasters in 20 years, with around 100 crore people affected. The majority percentage of people involved are those in poverty. A disaster shelter plays a critical role in supporting and protecting these people and is a crucial part of the resident community. During non-disaster times, a lodging facility with minimal rates is proposed. Many people who travel to Pune for work, studies, or pilgrimage cannot afford to stay in hotels, so they are forced to reside on roadsides. A short or long-term living facility can be provided to these people at an affordable rate. Further, the workshops will help educate people about crucial topics like climate change, etc. After selecting the site, preliminary design drawings were done to understand the working of the resident shelter. This helped us in coming up with an initial zoning. Next, the conceptual 3D model were made to design orientation, road layout, landscape, etc. The 3D model also helped us to deal with the gradual contour site. The basic concept of design for designing the structure was creating a hierarchy of space according to public, semi-public, and private use. Following the hierarchy, public spaces such as multipurpose workshops and libraries have been planned to be in the front, which is the northern side, for suitable accessibility. Semi-public spaces like the community kitchen which provide food at an affordable rate to both the public and people residing at the lodging have been provided further inside, which are located at an equal distance within the structure. The stay facility has been planned at the southernmost part of the site to maintain user privacy. The primary purpose of the stay facility is to provide lodging at an economical weaker section at an affordable rate. The service area has been provided near the maintenance road to allow easy and fast maintenance. The parking area as per UDCPR has been provided with an amenity space in the front. Medical and admin facility which also comes in the frontage. Instead of planning the space vertically, the entire structure has been divided into 3 buildings and spread horizontally to utilize the available space on site. This helps in making the plan more porous and more lively. The idea was creating seamless spaces, creating an indoor-outdoor experience. These openings helps in passive cooling and natural daylight entry. The buffer between different spaces show the transition from an enclosed space to open space through semi-open spaces. The hierarchy of courtyards is also seen in the view above. An offset of 7 meters has been left from all sides for fire tender movement. All the above steps lead to the following model, showing the final form and volumetric of the structure. The courtyards ranging from big to small, the semi-open spaces, and the windows provided at higher level all contribute to cross and stack ventilation within the structure. As shown in the slide, there is a 6-meter wide entry to the site and a parking space in the front. The narrow entrance to the site creates a serene avenue, enhancing the experience of the user. As you enter the structure from the foyer, there is library, multipurpose, and workshop at the beginning of the facility, which provides revenue to the structure. Moving in, there is an admin and medical facility. The medical facility caters to the emergency and has been given close to the entry to ensure easy access to the ambulance. Further inside, the community kitchen and dining have been placed strategically such that they serve the majority of the stay facility in the neighborhood. The placement of dormitory and stay facility allows them to have their private spill-out spaces and some separation from semi-public areas. The service area has been provided near the maintenance road. The frontage of the site makes up for an amenity space. Moving forward to the passive design strategies, to minimize the exposure of space to direct sunlight, the building was oriented north-south direction with dead walls provided on eastern and western side to reduce the heat gain from direct sun. The table 1 shows us the total solar radiation incident on various surfaces of the building for the summer and winter season, proving us that north-south orientation is more suitable. As seen in the traditional houses called Vadas in Pune city, a hierarchy of courtyards have been provided to allow maximum sunlight penetration and proper wind flow. It also acts as a community space that promotes interaction and helps recharge groundwater through rainwater percolation during monsoon season. The spill-out areas for workshop act as an extension, opening the interior spaces, which also serve the similar strategies. Evergreen trees on the periphery of the site act as a screen barrier to reduce noise and shade the eastern and western facade. Recharge pits have been provided to facilitate groundwater percolation. The courtyards are evenly distributed along the entire structure with landscape which have a therapeutic benefits and help people to recover during the hard times. The visible views of a central courtyard between the stay facility, showing how it helps in sunlight entry and passive cooling. While creating the floor plans, the vision kept in mind was to create a self-sustaining model that can be repeated to create a design. The utility courtyard helps in creating vertical garden, creating an indoor-outdoor experience. A modular design concept in housing was used, which was repeated around the utility courtyards. To reduce the heat gain of the structure, following strategies in facade were followed. On the northern side, double-heighted openings and more window area allow greater amount of diffuse north light to enter the units. On the southern side, single-heighted openings, jali walls, and louvered windows are provided. Further, dead walls are provided on eastern and western facade in order to decrease the heat gain of the building.
Even though Pune has a composite climate, non-comfort hours are significantly less, and therefore an active mechanical cooling system is not provided. Climate consultant was used to calculate the comfortable hours of the building. Further, we use passive strategies like stack and cross ventilation within the structure, which help meet the comfortable hour requirement. This section shows how the design strategies have been implemented throughout the structure. A rigid grid has been followed while designing the resilient shelter. The use of a rigid grid system helps in decreasing the cost and time of the construction. While selecting the building material, we intended to minimize energy consumption by implementing materials with lesser U value without compromising the occupant's comfort. The table compares the performance of different materials used in building construction in Pune city. The diagram shows how modules were replicated in stay facility to come to the final form, a self-sustaining structure that houses both active and passive design strategies and can be easily duplicated because of its modular design and low cost. The active design strategies used for energy efficiency in the structure are: lighting is an essential criteria that has to be considered while designing a zero energy building. It can contribute to the reduction of energy consumption by use of energy efficient fixtures. LED lights were used to reduce the energy consumption. To deal with the plug loads, appliances having a rating of 4 to 5 stars are used. Also, energy efficient water pumps are used. The benchmark EPI for the community resilient shelter in composite climate is 58 kilowatt hour square meter year. By following different strategies and methods, the EPI for the project was lowered to around 20.
The water cycle diagram showing water distribution from the municipal line to the resident shelter has been shown to achieve net zero in water. Strategies such as rainwater harvesting, where the harvested water after treatment would be stored and used during the disaster times. Water efficient fixtures and aerators have been also used. Water is being reused by treating it and on site using a water treatment plant. The courtyards act as a multifunctional spaces which facilitate groundwater percolation during the monsoon season. The road network has been planned so that the network covers a smaller percentage of the site. Thus, increasing the landscape in the resident shelter acts as a spill-out area for the workshop area and stay facility. This facilitates the interaction of users during the drier season and recharges groundwater during the rainy season. Using water efficient fixtures, up to 60 to 70% of water is saved compared to conventional water fixtures. Of the total water demand, the grey water and black water generated, 56% of the waste water is filtered and reused. Water treated after secondary treatment, 89% can be used for flushing and 11% of water can be used for landscape. This fulfills the water demand for both purposes. Rainwater collected accounted for 21% of the municipal water demand and 20% of the freshwater demand. As shown in the web diagram, the community resident shelter will act as a lodging available to the economically weaker section. The facility will provide them the accommodation at the minimal price. The amenity space present in the front will become a market area that will help uplift people during the disasters. Further, foldable furniture is provided in all units of the stay facility so that space can be lived with great flexibility and change its appearance during disaster times and non-disaster times. This view shows us how the space are multifunctional and how they can change according to the pertaining conditions.
One of the essential parts of a net zero building and community resilient shelter is to be self-sufficient, so that when a disaster strikes, the building can function on its own. Each building unit is provided with solar panels on the terrace with an on-grid photovoltaic system. During regular times, the energy requirements will be fulfilled by the primary electricity grid and the PV system. With a net metering system, any surplus energy produced is fed back to the grid for credits. The system can also work independently during an emergency. Solar panels are provided on the rooftop of the structure and are used to generate energy. Flat roofing system has been provided to accommodate a maximum number of solar panels. The community resilient shelter will aid the affected people to rebuild their economy by starting a small venture in the market space provided at the front. It will help them until they are economically stable enough to support their families. In addition, this space would be used as a multi-purpose space during non-disaster times. Each of the temporary units provided in the market area is modular unit of the same dimension and shape and can be duplicated on any given piece of land. The modules are made by a reinforced timber framework which are covered with tensile fabric.
The temporary shelters were designed in an innovative way which has multiple uses. The umbrella roofing system works on hydraulics and will be closed during non-disaster times. However, during disaster times, the structure will open up to form an umbrella roofing system made up of ETFE. The umbrella roofing system can be easily assembled into a temporary tent on site with the help of unskilled laborers within a short span of time during over-occupancy during disasters. The roofing system will act as a funnel and help in rainwater harvesting. The water collected is channelized to the water tank for treatment through pipelines.
To make the scheme affordable, the following strategies have been used, such as modular design have been implemented for designing of the facility. This allows in more efficient and sustainable construction. Repetitive modules of the same dimensions have been also used. Some of the advantages of modular designs are it reduces the construction time by 30 to 50%. The amount of waste generated by traditional construction methods has also been an environmental challenge for the project managers and stakeholders. Modular construction generates less waste than conventional construction, thus making it environment friendly. It is also cost effective as modular design considerably reduces the construction and labor cost as repetitive modules are used. Aerated autoclaved concrete blocks, that is AAC blocks, were selected for building the structure. AAC blocks are far superior in strength as compared to traditional clay bricks. Using AAC blocks, the construction time is reduced by up to 20%. The temperature regulating properties in AAC blocks make the structure cooler in summer and warmer in winter. This helps in reducing the energy consumption. They are easily available, so transportation cost is also less. Also, GFRP bars are used in place of conventional steel. These bars are 40% cheaper than steel bars.
In order to implement successful replication or large-scale implementation of the resilient shelter, the following strategies are used. Targeting the vulnerable states hit by disasters, interaction with user, organization, and stakeholders, the use of modular design, which can be replicated to create a sustainable module, housing both passive and active strategies. The use of the different repetitive modules of similar dimension saves construction time and cost. These modules can be easily repeated in different cities of India. The choice of material plays a crucial role in scalability. The building material used in this project are easily available all over India, and the construction technology doesn't require new skills for laborers. The use of these building material decreases the cost tremendously, thus making it feasible for large-scale construction. The reduction of construction cost will attract organizations to replicate the similar project in different states of India. Further, the replication of resilient shelter will also provide employment to the laborers, thus uplifting them.
We cannot stop natural disasters, but we can arm ourselves with knowledge to protect the community from these disasters. Post-disaster shelter programs which provide durable housing successfully, meet humanitarian needs and protect the vulnerable after disasters are a need of time. The improved acceptance, ability to maximize the value of shelter and contribute to effective disaster risk reduction were the goals kept in mind while bringing this project together. We would like to thank Solar Decathlon India for giving us this exciting opportunity. We further would like to thank the jury members, faculty lead, industry partner, and project partner.
Thank you.
Wow, you guys really finished on time. Let's hear from our jury members what they thought of your presentation. Vinay, do you want to go first?
Sure. So, by the way, congratulations to you. I think your team actually had some of the best drawings that I had seen. You know, the renders and the visuals that you guys had done were really excellent and
Thank you, sir.
very beautiful. Very beautiful. Gives everybody a sense of what you're trying to do. You know, the fact that it's not from outside, you're able to see the visuals were just outstanding. Good job. I just had one question, and this is kind of a question I had asked the first also. You proposed the use of AAC to make your entire uh, community shelter. Is there any other material you could use that would help you, or is there any other style of construction you could potentially think of using to save time? Because you know you want to quickly do this. What else would you do? I'd be happy to hear a few thoughts from one or two of you.
May I answer this question?
Yeah.
Instead of AAC, we could have gone with the conventional one. We could have gone with the hollow block panels. But instead, we went on for AAC because it was very easily available for the in the vicinity. It's cheaper as compared to the other methods. We had to make our project as much economical as possible. So that was the best material that was available in our locality in the cheaper rate as possible. And for,
go ahead.
Yes. Done, sir.
Did you consider any prefab?
We did consider prefabrication, but we didn't had any what do I say multiplications or repetitions of our structural components. We
So,
had
sir,
just
as
a G+1, G+2. Yes.
yes, so as we decided to spread our building horizontally throughout the site, so that we could bring in the courtyards and hierarchy of them throughout the structure to minimize the number of floors, and we avoided to go vertical. So as we didn't go vertical, we decided not to go with prefab because it will increase the cost. Because it's economical when you go vertical, and there are a lot of modules which are repeated. So that's why we did decide to go with prefab.
Sounds good. Thanks. It's clear. I wanted to know your thinking, and also I like your umbrella idea. Of course, when there is wind, rain, and all, consider what happens. Again, it was well demonstrated. Also, very well visual. So good job with all of that. Thank you.
Thank you, sir.
Thanks, Vinay. Anamika, you want to go next?
Yeah, sure. Congratulations, team. You've done an outstanding job. I think you've used the modularity very well to come up with a very distinct, design aesthetic, which is replicable, scalable. You've used, the hierarchy of courtyards. I like the use of jalis. It gives a very distinctive aesthetic, which I think has promised to, develop into a distinct vocabulary that represents such shelters. You're also one of the few teams that, thought through your renewable strategy and actually gave us a payback number of years. 6, I think, is what you've said,
Yes,
right?
yes, ma'am.
So I was happy to see that, and you had given thought to, net metering. So again, happy to see that as well. Your EPI number, I mean, it's impressive. There is no doubt about it. But it is something that needs. I feel it needed, a little more evidence in terms of your comfort studies. What are the operative temperatures you've considered? Have you considered a different standard? Considering the city of Pune. So I would have liked to see a little more on the comfort study side. But otherwise, yeah, in terms of, like Vinay said, your visuals, your presentation, the way the entire scheme has come together. It's done very well.
Thank you, ma'am.
So thanks, Anamika. Venkatesh, you want to go next? Venkatesh, you're on mute.
Yeah. Two of the points I wanted to touch upon have already been spoken about: the AAC blocks and the umbrella. First things, uh, you guys came up with a very culturally sensitive design, which is very nice. The use of courtyards, the way you handle that hierarchy of courtyards, and it's a architects know it's a subject much beaten to death, but the way you move from public to private as you went to the site, again that was done very nicely. Though I do have a little bit of doubt on, because your rooms are already occupied by people, so how will disaster time, what are they going to share it, or what it is something that didn't give me proper idea. But I mean, I just like the way you guys did that hierarchy. I again had this thing with the AAC blocks. Okay, I mean that kind of takes away a little bit from the resilience response. It is too permanent material. I kind of think that you guys should have been a little more experimental. I mean, your solution is not wrong. Okay, I mean you get full credit for your solution and all the calculations you did with it. But I just think that you could have pushed the boundary of this a lot more by looking at some of the alternatives, like come and plug in place kind of walls and stuff like that, because that gives you that flexibility, and that flexibility you already showed in that umbrella. Your umbrella opens up, it can serve as a cover, but you can also put that wall around it and it becomes a living space. That's again something that you demonstrated quite nicely. So I had a lot of things in it. I would just suggest, as a takeaway for you people, that next time you got to be a little more experimental with the design. If this design would have been perfect in any of the other groups, but for disaster resilience, I just thought it was like too conservative. But I mean, there's again nothing wrong with it, okay? Because this is just a very subjective point of view. But on the whole, I think your approach was really good, and you're also one of the teams that paid a lot of attention to the MEP. I mean, you kind of seem to have looked into actual market available, stuff, and then power consumption for that, and done your exercises. So that's kind of very nicely done. So good job. You can smile a little more. You should be proud of
Thank you,
what you.
sir.
Thank you, sir.
Thank you, sir.
Great. Thanks, Venkatesh, and thank you all jury members. So thank you, Team Alpha.
Yeah, good
That was
luck,
a
team
great.
Alpha.
Yeah,
Good
good
luck.
luck.
Thank you, sir. Thank you, ma'am.
Thank
Best
you.
wishes going forward.
Thank you so much.
So let's just take 5 minutes before we go into the next presentation.
Good luck, guys.
Thank you, sir.
So our next presentation is from Team Virya. They have worked on Arkachitra in Odisha, and their project partner is Selco Foundation. So can we just have a quick AV check? Janvi, can you hear me?
Yes, I can.
Okay, great. Rutuja?
Yes, sir. Yes, I can.
Great. Pratishta?
Yes, sir.
Great. And Shreya, can you hear me?
Yes, sir. So there's a problem. I'm logged in from my phone. Can you just wait for 2 minutes? I'll be logging to my laptop.
Maybe meanwhile your backup presenter could join in, and then you can just join in from then.
So at a time, our five team members will be in. Is that so?
No, I'll just take you out of the stream and add the backup presenter for now.
Okay. Thank you.
Okay. Yeah.
Sir, actually this is fine. Shreya, you can speak with this thing only.
Okay.
Yeah, if it's fine that you use your phone, it's absolutely fine. Yeah. Okay. Okay, so can you go share your screen and go into slideshow mode?
Yes, just a second. Is this visible?
Yes. Just a second. Yeah.
Can you still see the screen?
No, now I cannot see your screen.
Just a second.
Yeah, great. So
Okay.
you're in slideshow mode, right? Yeah. So you'll have 25 minutes to do your presentation, and at 20 minutes, I'll ring a bell like this. Could you hear that?
Yes.
Okay, and you won't have a 26th minute, which means at 25th at the 25th minute, I'll have to ask you to stop your presentation and end it. After that, we'll have a 15-minute Q&A session with our jury members, and please keep your answers direct and to the point so that you can get to answer more questions from them. Okay,
Sure.
team, the stage is yours. All the best.
Thank you. Good afternoon, everyone. Team Veer here introduces a holistic community resilience shelter, Arkachitra, precisely meaning a picture of the sun. Reflecting on the strong connection of the local community with the sun as the source of life and energy, we arrived at this on the eastern coast of India while looking for a site with our project partner, Selco. Team Virya depicts energy, diligence, enthusiasm, and effort. We are a group of 15 students from Pune with varied skill sets and a common mission. Today, Shreya, Pratistha, Rutuja, and me Jannavi will be presenting. We are guided by architect Prajakta Kulkarni as our faculty mentor. Let us hear what my friend has to say. So, this is a movie with a millet. So, the millet is saying, just a second, I'll reshare. Hi, I'm a millet. Did you recognize me? You might know me as Jowar Bajra Ragi. Just like you, my own people had forgotten me. My absence caused a nutritional crisis in my village, Badeguda. My cultivators Agriculture and forest being a major part of our livelihood, we shared a human nature balance. Various events in history destroyed nature's cycle by introducing water intensive cash crops and replacing nutritious millets. Climate change has increased frequency of disasters, adding to the recurring damage. Having forgotten our traditional ways of resilience and lacking a disaster shelter, we needed a durable solution to regain resilience. Odisha is exposed to recurring disasters like floods, droughts, and cyclones. We observed a concentration of government cyclone shelters along the coast that left the hilly belt along the coast underserved and unprotected, even though falling under cyclone risk zones. Our site, Badeguda, has a warm and humid climate. Badeguda is a remote tribal village with a population of 300 people. The village has poor connectivity, lacking all weather roads that limit the delivery of relief post disaster. The project site is central and accessible to the entire village within a walking distance of 100 meters. We came across some design questions with the context and need in mind. We asked, how can a net zero cyclone shelter protect a vulnerable community and enhance livelihood? How can net zero architecture increase resilience by involving people as stakeholders in disaster management and mitigation? How can a net zero community resilient shelter enable healthcare and also provide a nodal point for disaster relief? Architectural and engineering design contribute to our goals in terms of flexible planning, thermal comfort, energy performance, and structural integrity. The factor of innovation seeks to enhance the proposal with added convenience and security, thus ensuring a resilient design. Now, let us see all the layers of consideration. The risk profile of a cyclone brings along other phenomena with it. The site and disaster analysis led us to a tight set of constraints. The primary one being the upliftment of the roof. The roof angle has been decided after considering layers of streamlining, no permissible overhangs, and the angle required for solar panels to function without damage during disasters. The secondary constraint was the sizing and securing of openings. As a vernacular element, it was a challenge to incorporate courtyard that could be closed during disaster without affecting the circulation. Designing for various terrains led us to a guideline based customization manual for our standard solution. So let us see what the solution is. Over to you, Rutuja.
The site area is 7,900 square meters with a built-up of 2,300 square meter. The site slopes towards the west with a 6-meter wide access road on the east. Multipurpose hall, medical room, and logistics have separate entries with ramps for universal access. Cattle shed and the site services are located along the northwestern periphery of the site. Earth mounts and bamboo plantation on the east act as wind barrier, with the existing trees replanted on the periphery to reduce damage due to uprooting. Buffer zoning protects the main habitable spaces from the direct impact. Kitchen, dining, and toilet block have been clubbed together for ease of services. The area program shows adaptation of regular spaces to provide 65% habitable spaces and 35% support spaces for disaster use. The multipurpose hall, along with dining and a community kitchen, will be used for village events. The self-help group, along with a creche and a medical center, will act as support spaces. The logistics and agro-processing area will, with a seed bank, constitute the livelihood enhancement spaces. The toilet block, along with a covered corridor, will ensure use during both the cases. Preparation steps for disaster scenario include keeping communication systems on standby for coordinating relief operations, securing all openings with window protection system, stocking community kitchen with supplies, repairing medical unit for post-disaster diseases and precautionary vaccines, setting up mattresses and partitions for multi-purpose hall use, storing of existing produce effectively for use during and after disaster, and lastly, clearing out of the logistics for additional occupancy. The material palette consists of brick, bamboo, and steel sandwich panels with coir board insulation. The central courtyard acts as a community space and helps in providing natural light and ventilation during regular times. However, during the cyclone events, the courtyard will be closed and the circulation will be ensured by internal passages. The multipurpose hall will be used as a main habitation space with a capacity of 300. Additional 300 people can be accommodated in the logistics after rearrangement of the temporary stacks. The contextual parameters guide architectural character. The structural system used has a load transfer mechanism from bamboo space truss to bamboo columns and buttresses to the foundation. The openings are secured with the window protection system. My teammate Shreya will be taking over.
The major consideration for engineering design was resilience against cyclone wind impacts with a maximum speed of 70 meters per second. Massing of a shelter with a central courtyard in a place is done to withstand the maximum pressure limits. The study of wind pattern leads us to the conclusion regarding fenestration design for ventilation during normal operation and security against high-speed wind during the cyclones. The ball and socket joint will provide required flexibility against rupture during impact. The bamboo column consists of 6 bamboo cones for high strength. Moisture control is ensured by 1.2-meter high plinth with a protective layer of lime blast. Roofing joint detail is specially employed for holding the roof in a place. Bamboo buttresses provide additional support to the vertical members and anchors the structure. Bamboo create horizontal and vertical bands increases structural integrity against lateral loads. The top hung window and a double shutter side hung window constitute the cyclone resistant window protection, having the 3 modes of operation. The top part acts as a sunshade when extended outward. The locking arrangement of shutter is sturdy and convenient, resulting in hassle-free securing of openings from inside, replacing the recurring process of boarding windows earlier. Resilience is catered to by a detailed risk analysis and resulting detailed risk mitigation details. Out of the 19 risks analyzed, prominent considerations are highlighted. Provision of cross-bracing, lintels, sill band strengthen against the failure due to the lateral loads. Sheet piling will provide scoring of earth below the ground and retain the earth bumps. Tie beam at a plane strengthen against the uprooting of the building from the ground. Trees are placed 9 meters away to avoid the damaging the structure. So, how many days of the autonomy is achieved by the solution? The cyclone shelter will provide 6,500 plus hours of the thermal comfort with the passive performance. 20 battery storage capacity for the 2 days each will cater to load requirements. The shelter will run for 12 days with the provided water storage. 5 solar cookers provided will ensure a sufficiency for 15 days. The medical room will provide medicines for 15 days and the medical equipment will run for 5 days. 6 handheld amateur radio walkie-talkies will run for 5 days. The shelter attempts to provide 3 forms of resilience: structural, economic, and social. Structural resilience ensures no recurring damages and repair costs while keeping the day-to-day functioning intact. Economic aspect provides opportunity for the generation of income of the quicker economic recovery. Social resilience is enabled by the involvement of community in a disaster management and strengthening the social bond. I'll be handing over to my teammate Pratish.
The goal of net zero energy performance is achieved through site management for optimum water performance in an area where clean drinking water is a scarcity. Thermal comfort through passive design, energy performance through solar design, and load reduction strategies further contribute towards a sustainable community shelter. The aim is to minimize water consumption on site as the basic step to net zero water cycle. The contaminated groundwater is not being used, and the only source of water is a stream located near the site. A critical water storage tank acts as a reserve tank for increased demand during disaster scenarios with 300 occupants. 20% of total water capacity is stored in these critical tanks. The collected rainwater is first filtered through Devas filter fitted in the downpipe. It then passes through sand filters to be collected in underground storage tanks. For cooking and drinking, charcoal filters are used to further eliminate harmful elements from the water. Additionally, loft tanks are also provided above kitchens and toilets. The recycling of water is divided into two parts. Grey water recycling for secondary activities such as washing, bathing, cleaning is treated with the help of root zone system. The treated water is then used for irrigation and flushing. During disaster, the capacity of reed beds is scaled up from 2 beds to 4 beds. 75% grey water of the total consumed is recycled on site. Black water from flushing is collected in septic tanks for further treatment. Required air changes per hour, appropriate wall-window ratio to reduce heat gain, and maximize daylight are considered to provide openings in each space. Skylights are installed to improve indoor light quality. Provision of a courtyard improves cross ventilation, and naturally operated turbo ventilators facilitate stack effect within the spaces. We looked at local availability of materials, cost, and their impact on the environment to select a sample size for comparison. Based on these considerations, double glazing glass for windows and polycarbonate sheets for skylight was selected to reduce heat gain. Fired bricks for walls and coir pit insulation are used due to ease of availability and their low environmental impact. Further, permutation and combination of different assemblies and ventilation setups resulted in a comparison of 3 cases for optimum selection to maximize comfort hours. The selected envelope assembly with greater thermal mass leads to increased time lag, which allows for comfortable indoor environment during general occupancy hours of the day. 75% of thermal comfort are achieved passively. The use of locally sourced materials such as bricks and bamboo reduces efforts in transport, manufacturing, and construction, which in turn reduces the overall embodied energy of the structure, thus reducing appliance dependency for cooling and reducing energy loads. Use of 5-star rated energy appliances for lighting and ventilation increases efficiency by an average of 45%. This helps us achieve an EPI of 40, which is 27% below the target EPI. The reduction in loads leads to an optimum solar design, which caters to the energy requirement of the community shelter during normal and disaster scenarios with increased loads due to larger occupancy hours. The loads are calculated to balance the requirement in both the cases. The solar design ensures that the energy demand remains equal in both the cases by diverting loads from non-essential areas to critical operations, such as the medical sector, where demand is likely to increase during the disasters. The PV system generates electricity to offset 100% of the total consumption. Back to you, Rituja.
With the net zero water cycle and net zero energy system in place, let us now try to understand why Arkachitra is a holistic solution for the upliftment of any community. Quick assembly on site, replicable and modular design has contributed to control the timeline and overall cost of the project. Use of passive strategies for natural ventilation instead of HVAC has reduced capital and operational costs, ensuring maintenance without need of skilled technicians or special spare parts that aren't available in the remote areas. A DBFO business model has been used such that during the concession period, Selco owns and operates the facility partially, later transferring it to the Gram Panchayat. The agro-processing unit and resilient farming technologies are promoted for higher yield. Self-help group and healthcare access will improve parameters of economy and health. Sustainable alternative use of multipurpose hall will provide functional flexibility. The shelter will act as a, in the given scenario of pandemic, will act as a isolation center with the provision of oxygen concentrators in the medical specifications submitted in the report. Use of local materials instead of RCC and natural ventilation instead of HVAC will reduce costs. Creation of a bamboo prefabrication unit will serve as a material resource hub by setting up a local supply and demand chain in the neighboring villages. This community resilience shelter is a widely applicable solution to disaster problems scaled across India, achieved by collaborating with different government schemes such as Millet Mission and Mission Samruddhi for Millet Revival, Mission Shakti and Odisha Livelihood Mission for Economic Empowerment of Women, and National Bamboo Mission for supporting the use of local bamboo. Thus, we can positively conclude that Arkachitra is a solution which seeks to address the questions of vulnerability and inculcating resilience by protecting 300 plus villagers of Badeguda, providing an agricultural resource center for livelihood enhancement, access to healthcare and creation of a nodal system, use of local materials and less resource intensive systems, bamboo prefabrication unit for local supply and demand, sustainable business model for its year-round use, and lastly, self-sufficiency through net zero energy and water cycle. With the thoughtful use of resources and the right tools for decision, let's make a sustainable future. Thank you for your patient hearing. We would now like to address the questions.
Wow, I didn't have to ring my bell. So you guys finished well in time. So I think let's get the jury's comments on this. So Venkatesh, you want to go first?
I'll go
And by the way, just a minute, we also have the project partner of the team present here with us. So yeah, Venkatesh, you can continue.
Yeah. Early this morning we had another site, Wayanad, and among the sites chosen, I love Wayanad and Orissa in a very kind of a perverse way, because when it rains in Wayanad and there's floods out there, or if a cyclone hits Odisha, there's water in Chennai. You know, our water security is taken care of every time there's a good cyclone in the Bay of Bengal, which typically misses Chennai and goes and hits Orissa. So Orissa disaster site is something that tugs at my heart, and you guys have actually done a fantastic job, because every single thing that I think is relevant to a disaster, you guys have ticked that box. I mean, I can go on and on, but at the 5th minute, I think Srijit will cut me off, so I'll be fast. First of all is use of local brick and bamboo. You guys have used bamboo really well, not just for the trusses and for the the tie beams, etc. Your idea of that buttress was very good, and it was kind of a nice visual element. I mean, this is a kind of a visual element that can actually become like a symbol for resilience. I mean, this kind of a triangular design is really nice. It'll become the logo for an Odisha Resilience Corporation if it's ever done. And the fact that you use it as reinforcement in the wall is also something pretty remarkable. I love the detail for that storm-proof window that you guys did. Again, a very nice detail. The way you used the courtyards and the process. Obviously, you couldn't touch upon it in this presentation, but in your documentation, you've done a really good documentation on how you arrived at that process of form and use of courtyards, the coir insulation. So somehow you used all the right material, which is basically agrarian in nature, which can be used as a low cost for a template of disaster resilience shelter. So on the whole, it's a really great job that you guys did, and I like the fact that you used a lot of daylighting also. So your baseline energy consumption was was really low, which helped you also to get easily to net zero. I mean, all is not good. I'll have to leave you with one or two things to think about also. So one of the things that all of you don't do properly is like water. And if you had underground water which takes care of disaster day, then you should at least shown us that it is in the highest point of the site. Because typically, if that gets contaminated, then you have a problem. So that aspect didn't come out too clearly. But on the whole, really good job, team. I mean, you guys should be really proud of what you've done. Congrats. Very well done.
Great,
Thank
great,
you, sir.
great. Vinay, you want to go next?
Sure. So it was a very nicely done report, very nicely done presentation. So thank you for the good work. I think the high points for me was the, the resilience part. I think I really like the way you had addressed it in the report. It was like 1, 2, 3, 4, 5. These are all the problems. These are all the solutions. And you look at it and you know, okay, fine, your structure is resilient. So, and I like that clarity that actually you brought to the report. So, and I also saw that you had also attempted some CFD simulations to look at wind flow and all of. So, all of that for me are pluses. I just have one question to ask you, and I just like your basic thoughts on it. What's the speed of construction with this current setup, and any ideas you might have to improve it?
Rutuja, would you like to answer that?
Yes, sure. So, as per the construction technology that we have attempted right now, we aim at completing the construction within 2 years. So, like for now, it takes 2 years, but with the, like as I mentioned in the scalability point, that we are proposing to have a bamboo prefabrication unit. So this would create a local supply and demand and supply chain. So for the first time, like in Badeguda, probably it would take 2 years, but if we consider the bamboo prefabrication unit in place, the construction period would considerably be reduced.
So that's the point I wanted to bring about, because I honestly think that the time taken was quite a bit. 2 years. Life is moving very fast. That was the only one. That was one feedback from me. And by the way, I didn't realize this was also an all-woman team. So congratulations, and happy to see you here like this.
Great, great. Thanks a lot, Vinay. Anamika, you want to go next?
Yeah, Venkatesh and Vinay stole my notes and my adjectives. So I'm at a loss of words. The team has done an outstanding job of, attention to detail, context, technique, and also narrative. Yours was the easiest a set of documents for me to follow because you walked me through your thought process, and you pointed out the cons, and then you presented the pros for your structural analysis. And it's a very, very holistic approach to design where you kind of buttressed it with the way you started your presentation with the millet talking. So it's not just the architecture that you're thinking about, but the entire the agrarian context. And that's why you've also come up with unconventional non-disaster time uses for this building. So all good. I just my one concern was while the architectural vocabulary you've arrived at from a structural point of view it's resilient, but I think you have a very deep building footprint. So you may need to address that in terms of daylighting and natural ventilation. And the other thing that was bothering me, and maybe I'm wrong, is that I feel your numbers for the renewable, generation capacity, I think it falls short. So you may want to, revisit it if the project actually is built someday, and I hope it is. But yeah, those two were the only things that kind of, I felt that you may need to revisit. But otherwise, great job.
Thank you.
Thanks, Anamika. Thanks a lot for giving your comments. So we also have Akshata from Selco Foundation who has joined in. So Akshata, a few words about your team's presentation. Hi, Akshata, can you hear me?
Hello. Till the time Akshata gets back, can we address two of the issues about daylight and renewable
Sure.
energy?
Yeah, sure.
Pratishta, would you like to take over? I'll go to the relevant slide.
Yes, sure. Are you on the right slide? Uh, yes, ma'am. So for optimizing daylight and still reducing heat gain, what we did was optimize the wall window ratio first, which came to be about 20%. And then additionally, since we have a modular plan, so the planning has went accordingly, and the daylighting has been superimposed onto that plan, and we have seen if we can work that out if additional modules are added as well. So that's why we have added skylights for added daylight within the deeper spaces.
Right.
And as for, can you move on to the solar panel calculation, the slide? Yes, this is it. So, while calculating, the major differences between energy loads was from LPD. So we calculated according to the ECBC as well, and then according to the Celco tech team, as they guided us with the LPD and shared with us the thumb rule, where we take 10 wattage of bulb for 10 square meter areas. So we went through different brands and identified which brand would give us good rating, 2000 kilowatt hour per year. And what we are generating as per the MNRE resources, where 1 kilowatt power provides us with 4.6 kilowatt hours of electricity per day, we came at a result of 92,460 kilowatt hour per year in terms of electricity
Yeah,
generation.
that
So
sounds
we
right.
have a, yes.
Also, I would like to add that in the earlier stages, we tried doing some basic monolithic forms, but we realized after adding a courtyard, the daylight issue is mostly getting solved. So what happened in the daylight type, the courtyard typology was we need like in a regular courtyard that is in vernacular studies that we found, it always has a circulation passage, and closing that was cutting off the daylight. So currently the courtyard has been incorporated in such a way that the daylight is not restricted to the multi-purpose hall as well as the logistics. So this covered corridor which will ensure access inside when it is closed during cyclones. So after adjusting the courtyard, we could also use it for the daylight of these other spaces.
Right, point taken.
Okay. So we are having some. I think the project partner is having some internet issues, so we may not be able to take a comment from them at this time. But yeah. So thanks, Team Virya, for doing such a great presentations, and the jury is really impressed. So moving forward, we'll just take a small break now. We'll start our next presentation at 3:45, and jury members and the last presentation team, which is Team Bombay Squadron, you can join. At 3:45 minutes prior, so that we are on time. So we'll be back after this break.
Just a
Yeah.
quick question. Can I ask it here or do we take it? What happens after
We'll
the
take it
5 minutes?
offline.
Oh, okay.
Yeah.
Shijit, unmute yourself, please.
Yeah, hi guys. So welcome back to the Community Resilience Shelter Division. We will continue with our presentation, and the last and final presentation of the CRS division is from Team Bombay Squadron. They have worked on a project Ashray in Mumbai. And their project partner is Maharashtra Social Housing and Action Lead. So can we just do a quick AV check? Pallavi, can you turn on your mic and camera, and can you just
Yes,
do a
sir.
quick check? Yeah, great.
Yes, sir.
Aniket,
Yes.
can you go next? Yeah, great.
Yes, sir.
Yash, can you hear me?
Yes, sir. Yeah.
Yeah, great. And we also have Nishiganda. Can you hear me?
Yes, I can.
Okay. So are the jury members back after the break?
Yes.
Okay, great. Anamika, are you there?
Yes, I am.
Okay, great. And Venkatesh? I think maybe we'll wait for a couple of more minutes. Yeah, great. Even Venkatesh is here. So I think we can begin our presentation. So team, can you just go into slideshow mode? Can you share your screen and go into the slideshow mode?
Yeah, it's already done. I'm sharing it.
Great. Okay. So team, you'll have 25 minutes for your presentation. And at 20 minutes, I will ring a bell like this. Could you hear that?
Yeah.
Yes,
Yeah.
sir.
Yeah. So I won't be extending your time for another 26th minute. So which means you'll have to stop at 25 minutes and end your presentation. And after that, we'll have a 15-minute Q&A session with the jury members. And yeah, so we are pretty much good to go. The stage is your team. All the best. You can start.
Ashaya, the feeling of happiness, adaptability, and resourcefulness in the time of difficulty. We tread, follow path. Where do they lead? What does the future hold? The world we
Just
call
a
our
minute.
home, does it
I'm
prepare
not
us?
able to change the slide. Yeah, continue. Mission.
We tread, follow path. Where do they lead? What does the future hold? The world we call our home, does it prepare us for the uncertain future? Can we as people create a home that protects, nurtures, and rekindles? A home of unknown origin but infinite possibilities. The inception of such a space for the community will mark the beginning of an era of resilience, quite possibly the world's saving grace. Climate change has brought untimely natural disasters with destruction and demise. India is no exception. From this arises a newfound need to prepare ourselves for the worst to be resilient. Community resilient shelters are home to the homeless, food to the hungry, a ray of hope to the lost. The concept of community shelter may not be new, but that of a resilient shelter not yet held in the Indian urban realm. This brings us a platform for ideas, innovation, and potential to set a benchmark for the future interventions. Holistically, the shelter will emphasize enhance social cohesion, health and safety, and the mental well-being of ones who seeks the help. It would set a precedent on how future cases would be approached. In our journey, we started by setting some goals which helped us achieve resilience. Architecture to achieve well-lit and ventilated areas, optimizing overall building functions with help of apt passive design strategies. thermal comfort to achieve year-long comfort, energy performance to achieve benchmark EPI of 55 kilowatt hour per meter square, renewable energy to generate energy on the site with minimum of 18 operating hours, resilience, the ability to sustain in every situation, water performance to achieve net zero water, adaptability to make spaces adapt in as per the need, effective technology to optimize energy usage and water performance, engineering as a tool to ease construction, to make the facility affordable to the context, and last, achieving shorter duration for construction. As we move forward, the mini graphics to the left indicate the contest and our approach for the same. The site chosen is located in MMRDA ground, BKC, Santa Cruz East, Mumbai. The site is currently used for COVID-19 isolation and vaccination centers. Ownership of the building lies in build, own, lease, or operate. Maintenance is taken care by the proposed business model through which various spaces are leased or rented for numerous activities. A portion of facility would also be used by various NGOs. Our target population is 200 occupants with a focus on the underprivileged ones who are more vulnerable to these disasters. The operative hours we have targeted is 20. According to the disaster risk management document, Mumbai is more vulnerable to natural and man-made disaster than any other city in Maharashtra. Floods in the past had catastrophic consequences. Economically weaker section accounts the majority of the population. These people are the most vulnerable to these disasters. After analyzing city based on vulnerable communities, MMRDA ground was chosen on the basis of safety and its proximity to these areas. The site is well connected to roads, metro lines, airports, and other facilities such as hospitals and institutions. The site has potential for infrastructural development, revenue generation, and accessibility to various resources. In Mumbai, climate stresses include high humidity and warm temperature throughout the year. High wind velocity is observed from west, southwest, and north annually. For 5 months, 75% comfort hour, while the rest of the months shows 100% discomfort hours. Keeping in mind the data from climate consult that have contributed to achieve the comfort includes adaptive comfort ventilation, cooling, dehumidification, and sun shading of windows with access road on adjacent sites. The predominant wind directions are west, southwest, and north. According to the site analysis, basic zoning was done by segregating spaces based on priority of their accessibility during disasters. The massing was designed based on a grid. The built masses have been separated into two sections by intervening courtyards. The stilt allow maximum daylight penetration. The angular fins is an addition, with addition to the shading devices, help reduce glare and achieve uniform distribution of light. These add up to the aesthetics of as well. The unidirectional wind towers is proposed to enhance the ventilation in the dormitories. The building orientation was optimized to minimize heat gain and cooling load. The 0-degree orientation was chosen for its effectiveness as it receives 40% of radiation and 70% of sunlight hours with better air circulation. According to zoning, massing iterations were done and simulation were run at different time periods. The improvement in EPI reduction and discomfort are helped us better design to take better net zero outcome. Access has been provided for an ambulance which would take the patient to the medical facility through the ramp. And open space for the workshop, which an open area for workshop which can be used to set up deployable tents can accommodate more people. On the left are the service areas which include transformer, electrical, and inverter room. For a calm state of mind, a shaded pathway leads us to the sensory garden. We have incorporated interactive spaces like Kund, which also help us to retain water. Area highlighted is the underground water tank. A root zone system has been proposed which blends well into the landscape. This space is allotted for public events like exhibition, flea market, which will generate revenue. And easy access parking is adjacent to the main road. The use of native species, semi-covered walkways, the permeable surface areas, and shaded parkings are some of the site-level strategies that has helped us to reduce thermal stresses. Native plants, locally available concrete blocks for grid paving, and salvage wood for landscape feature are chosen with affordability and climate in our mind. Grid-based planning makes the admin, medical facility, community kitchen, and workshop easily accessible during disaster. As the shelter is G+2, the central core consists of one stretcher lift and one staircase for vertical circulation. The common toilets are placed under the still so that they are easily accessible from the dining area. A ramp has also been provided to make the structure universally accessible. The first and second floor courtyards open to, the first and second floor corridors open to the courtyards. The mid terrace has a roof over provided with the solar PVs. This serves as a gathering area that could double up the accommodation when needed. In the dormitories as well, we have provided sanitary station for women. In the disaster time, balconies would offer a few moments of peace. The facility has two-phase activity plan during disaster and pre or post-disaster times. During disaster times, the workshop space would be used as an extension for the medical facility. The dormitory is equipped with foldable or movable furniture, which will allow efficient uses of space. The still floor acts as a shelter for animals. The community kitchen would serve free food for community. During pre or post-disaster times, the workshop space will be used for training sessions. The dormitory will serve as a night shelter or classroom. The still floor will be used for to conduct mock drills. The community kitchen would provide a tiffin service supporting the dabbawalas who lost their occupation during the pandemic. The pre and post disaster activities in Ashraya organized by NGOs would include education, library, skill development, women empowerment, and child care counseling. Our business model to help the facility sustain would empower the slum dwellers nearby. Ashraya would provide employment opportunities to construct labor and bamboo artisans and many more. The central courtyard enhances daylight ventilation and also serve as a rainwater harvesting pit. The spaces in the shelter would promote visual connection and interaction amongst the occupants. The dormitory volume has been designed keeping in mind the comfort for the occupants. The clear story windows, which light shelf, add ample amount of light and ventilation to the space.
After optimizing the orientation of the building, the heat gain from the southeast and southwest had to be received. The HSA and BSA angles are calculated for peak months and timing, which aided the design of shading devices. Our aim was to provide uniform daylight in the spaces. The areas to south, east, and west side show at least 10% of annual sun exposure, which can be controlled by the use of blinds whenever required. On the ground floor, an average of 70% of daylight is achieved annually. 67% of daylight is achieved on the first floor and 70% on the second floor. Light shells on the north help reflect light to the interiors, and the reflective surface helps increase the illuminance. All the spaces on the ground floor, first and the second floor, achieve the target lux levels as prescribed by the NBC, while spaces on the first, second, and also comply with the super ECBC set target. We observed the 3% increase in daylighting in the final case compared to the preliminary case. The angular walls with the louvered pins on the south facade reduce the heat gain and cut glare. The requirement for artificial lighting is reduced by 35%. An efficient glazing specification is adopted with 0.58 SHGC and 72% PLT. Since the deliverable 1, the design has evolved to optimize the efficiency of the building. The strategies used are cross ventilation to optimize ventilation, wind hours for for directing the high velocity winds to the lower level openings, allowing cooler air to reach the dormitories and courtyards to funnel in the wind, which will act as a thermal buffer. The preliminary case had a lesser number of outlets, which resulted in failure of cross ventilation. In the final case, the airflow network is improved by the increasing the outlets and orienting the openings to the west. According to ECBC, the minimum required for warm and humid climate window to floor ratio is 16.6%, and we have achieved 21.3%. The comparison graph of discomfort hours annually shows that the building does not meet the goal of unmet hours with natural ventilation only. We have opted for mixed mode ventilation to achieve the thermal comfort hours goals. Using mechanical cooling systems, the unmet hours are 214 hours, which is less than 300 according to Energy Simulation Protocol as per Appendix G of ASHRAE 90.1.2010. We considered 4 different cases during our design process and compared them based on the parameters shown in the table. Case 4 worked efficiently compared to the other 3 cases, and its EPI was within the benchmark set. The reduction in heat gain was observed during various energy conservation measures. In case 4, the roof slab consists of a concrete slab with pool motor, 40 mm pool motor and 20 mm SRI tile with a resultant U value of 0.132 watt per meter square Kelvin. Saint-Gobain single glazing with dewdrop color shade of U value 5.6 watt per meter square Kelvin. The wall assembly consists of AC blocks with external cement plaster, internal gypsum plaster, and bitumen waterproofing. The U value for the wall is 0.4 watt per meter square Kelvin, and the roof and wall assembly, along with BLT and window to wall ratio, complies with ECBC 2070. We have used Daikin's VRF system for mechanical cooling. For maximum efficiency, the outdoor unit with coefficient of performance 4.33 is used, and the indoor unit has been considered for maximum occupancy. The distribution system consists of 20 TR ODU unit for the ground floor serving 16 indoor units of 1.6 TR each. For first and second floor, 33 TR outdoor units serves 28 indoor units of 1.5 TR each. Different remote controls serve for respective indoor units. Further, the case 4 was evaluated considering VRF and radiant cooling system. Though radiant system had 0 unmet hours, its EPI exceeded the benchmark set. VRF system has less energy consumption, thus results in less EPI, and therefore VRF system is preferred over the radiant cooling system as it dehumidifies the indoor air. Throughout the interior space, you will find that all the appliances are Energy Star rated. The total annual energy consumption of the building is 1,75,101 kWh per year. The total annual energy generation by photovoltaics is 3,23,244 kWh per year. We have surplus energy of 1,48,133 kWh per year. Here, the building has achieved a net positive benchmark. Pre or post disaster, the energy generated per day will be 405 kWh per day. This energy is enough to be used for a period of 20 operative hours, in which heavy electricity consumption systems like HVAC lifts will only be used when required. As surplus energy is generated, the required energy for the working of the building will be stored in the battery room. Therefore, ASHRAE will be on-grid for net metering during post or pre-disaster and off-grid during the disaster times. We felt the need to conserve natural water sources by reducing, reusing, and recycling water. According to water demand in times of disaster, grey water generation is 15,935 liters per day, while the black water generation is 3,473 liters per day. According to water demand, we recommended low flow fixtures which reduced water consumption by 30%. Various systems like a root zone system, STP, rainwater harvesting system allow us to reuse 85% of water. Rainwater is harvested during the monsoon, and in other months, treated water will be used for all the other purposes. Our monthly water demand is 6.3 lakh liters. Water storage graph would rise above the necessary level by the addition of harvested and retreated water. The storage tank capacity is 44 kiloliter per day, which is twice the daily consumption. The UGT is located beneath the dining area. The water inlet to the water supply line, 4.8 kiloliters of water, is directed to the solar water heaters. The RO plant helps fulfill the drinking water requirements in times of disaster. The root zones treatment system helps reuse grey water, and the sludge from the STP is discharged into the urban sewage lines. Once treated in the STP, a second stage filtration is carried out by the root zone system before the water reaches the sedimentation tank. This entire system camouflages in the design landscape strategically. AAC blocks are used to cut down on construction time. They are widely used in India as well as in BKC sector, which reduces transportation costs and carbon footprints. AAC blocks improve sound insulation and thermal insulation, which decreases air conditioning cost by 30%. Since these blocks are lightweight, they reduce the dead load and help reduce the reinforcement in the structural framework. The joineries worked out required no skilled labor. The structural frame is standardized, which can be transported to the site easily. Precast construction technology for the structural framework is being used to speed up the construction process. There are several precast manufacturers near the site's venue, resulting in significant time and transportation cost savings. In the event of catastrophe and the need to construct the structure in several places, precast technology has proven to be more cost and time effective, and the construction will be completed within 1 year.
The cost of construction was greatly reduced by switching from precast panels to ACC blocks in the final stage. Almost 50% reduction in civil work can be seen. Symmetrical planning and modularity contribute to reduce the cost and complete the project in less time. The basic principle was to ensure that every single individual would have access to the safe shelter without having to travel more than 2.25 kilometers. Hence, the shelter could be repeated within the radius preferably. For the city level scalability, the shelter could be replicated with ease since it is planned in a grid-based method. In the event of tragedy, deployable temporary tents can be set up to accommodate more number of people. The site level landscape includes native species which are easily available and are cost effective. Renewable energy potential can be increased by providing solar PVs on the roof of parking and other areas. Symmetrical planning and modularity also help resist earthquake and wind loads. Since the terrace is covered by a roof that houses the solar panel installed on the space frame, it can be converted into a temporary accommodation facility in the case of increased occupancy. We produced 405 kilowatt hours of extra power per day, which is enough for 20 hours of power outages. Provided twice as much water storage that was required, reducing the municipal water demand. The workshop area will accommodate additional beds for medical facilities. Movable and foldable furniture is provided, which can help us house 100 people in times of pandemic and accommodate maximum of 200 people. The in-house community kitchen would support the food requirements for the facility for 24 hours. By providing ample daylight through the openings, we are able to achieve 100% of comfort zone in a shelter. We have considered the occupants' mental health by providing the relief areas like 5 senses garden.
The project intent is not only to design a community resident shelter, but also to strengthen the community and ensure their safety in terms of mental, physical, and social well-being. To reach out to each individual who seeks help during disaster, we propose an application that would help these communities notify us at the earliest and help them relocate to the nearest resilient shelter. Along with this app, we will showcase the other social events and programs to people during the normal times. Deployable bamboo tents allow room to accommodate increased occupancy. Each unit measures 4.5 by 4.5 meter, which accommodates 6 people at the same time. The tents have flexibility to multiply modularity to accommodate more people. The framing is bamboo members which are deployable, which allow flexibility for short storage when not in use. These tents would have a bamboo plinth for protection from rainwater as well. Recycled plastic sheets as a roof cover has been chosen. These tents could be deployed in the open spaces and could be used for storage as well. In turn, we create employment for bamboo artisans in the close by slums, empowering them. The project achieved the goal set and overachieved the set benchmarks. Architecture, 60 to 80% well-lit areas. Thermal comfort, 97.4% hours. Energy performance, EPR achieved is 55 kilowatt hour per meter square. Renewable energy, the shelter is net positive with some energy stored for 20 hours of operation during complete lockdown. Resilience, the shelter sustains in pre, post, and during the disaster. Water performance, it achieves a net positive water benchmark. Adaptability, the overall cost is reduced by 35 to 40%. Spaces are adaptable to any situation. This flexibility of spaces also contributes to resilience of the shelter. Efficient technology. Shelter encompasses efficient fixtures which help to reduce 30% annual water and also reduce energy consumption by 50 to 60%. Engineering, automation and ease of construction. Cost of construction. The grid-based planning and modularity speeds up the construction time and is cost-effective. Time of the construction. The time is reduced by 30% compared to the preliminary stage. We thank our mentors who guided us at every step of the way and supported our vision. Mashal, our project partner which is NGO working for underprivileged, and BKE Environmental, our industry partner who believes in promoting sustainability.
A team of BARC and engineering students who thrive to provide a most efficient output while refusing to settle for less. We share a strong bond. We would like to thank Solar Decathlon for this opportunity.
Thank you.
That was a really great presentation, team, and you were really ahead of time, and I should congratulate you for that. So next, we'll have our jury impressions, and we also have our project partner of Team Bombay Squadron with us here, Mr. Sharad Mahajan from Mashal. Hi, sir. So first we'll go with the jury impressions. Venkatesh, I'll start with you.
Kind of made me an opening batsman most of the time. Again, team, you guys did a great job. Your presentation was Mumbai Squadron. You guys did a great job. Your presentation was top class. I'm known for telling stories, so I'll have to tell you a little story. I designed a sports hostel for students for the Tamil Nadu Sports Development Association, and these guys came to me afterwards and said, "We find it very difficult to use your sports hostel." I said, "Why?" They said, "It's too modern for us." So, the only complaint I have against your design, which is otherwise, your presentation was good, it was comprehensive, you touched upon all aspects. The only complaint I have against you is you could have been a little more frugal. This is really like a 5-star resilience center, I mean, that's about the only complaint I can have, but that again a very subjective complaint. So it's really not something that I can hold against you. Your designs were very good. I like the idea of that wind tower. I've never seen it in Bombay though, so I'm not sure how it works, but it's definitely an experiment worth trying. It was very good. I like the idea of the stills for animals because that is something that you guys really focused upon. And we also the first group where I actually saw the animal graphics. And then I had to go back to the other groups to see what the graphics were like. So good job. I'm always a little skeptical about what you people do for water. I'm not convinced about it because all of you depend on underground water storage, and that's the first thing that gets contaminated at least in the flooding situation. So I would have depended a little more on overhead water storage. But that's a complaint I've had against everyone in your category. But that apart, really good job, and your graphics was top class. All the best.
Thank you so much.
Thank you, sir.
Thanks, Venkatesh. Anamika, could you go next?
Yeah, sure. For a couple of minutes, I forgot that
this was a student design competition because the quality of the presentation was so high. It was at a professional level, and the architecture, you have detailed it out to that level. This would be an office making a presentation to a client. So congratulations on that. You've
Thank you, ma'am.
Thank you, ma'am.
you've generated very interesting volumes. Your massing is very nimble with the stilts and the courtyards and the corridors. I really like the architectural aesthetics that you have used, and also the way you have used passive strategies to lend an architectural quality to your proposal. I like that as well. And one of the few teams that has given us like an iterative a process for daylighting, for natural ventilation, and for comfort conditions. So all good on those points. I just had some doubts regarding your renewable energy generation potential. I do feel you have overestimated that, and maybe I've not gone through the details well enough to say that with some confidence, but that is my general impression. And also on your VRF system, can you tell me what is the what overall TR are you using? Is it 83?
No, ma'am. It is 172 TR for all the
170,
floors.
right?
Yeah.
So for a conditioned area of about 1400 square meters, I'd say.
No, ma'am. The conditioned area is
It is around
Ma'am,
that. Hello.
I'm sorry, how much?
It is around 1500 to 1600.
Okay. Yeah, that just seems a little high to me. But again, these are just very superficial comments for an otherwise very well laid out um, um, proposal and presentation.
thank you, ma'am.
Thank you.
Tha-
Thank you, ma'am.
Thanks, Anamika. And lastly, Vinay.
It's very nice presentation. In fact, yours was the other group whose visuals I really enjoyed. The way you had rendered, the way you had shown the arrows of ventilation. The report also was excellent. The way you had addressed it section by section, uh, nice, and excellent job done. Especially in terms of the way you are presenting, filing the. There were some sections you had addressed beautifully: energy, thermal comfort, the architecture, the engineering. I think some of those you had addressed beautifully. I just wanted to. There were some sections where I honestly thought some more elements would have been put. And maybe I'll use this discussion to hear from you. What the top, uh, the most innovative features of your proposal? Anybody can just go for it.
yes,
Aniket,
sir.
you can
So
take over.
yes, sir. So, sir, as we have emphasized on temporary accommodation the most, which we have also focused in the scalability factor. So, first was the prominent thing was the design of the tents, which we have done for the temporary accommodation. And also the second thing, we thought of now connecting the community online as well by the Ashray Net Zero app. So, according to our project, these two were the prominent key innovations we did.
Okay. And anything you feel you could have done more from the material you're using? If I remember right, you're using AAC, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Any other proposals, or you feel AAC is the best way to go?
Sir,
Actually,
yeah.
yeah, go ahead.
Yes, you can go.
Yeah, so we
So,
thought
sir,
of
yes, you
we
can
thought
go.
of cavity walls as well,
Correct.
but due to the diurnal temperature variation, cavity walls are not that good enough to dissipate the absorbed heat during the daytime. So in the evening, it still holds that heated air inside it. So that rather the AC are much better to dissipate it.
I would also like to add here, in the aspect of affordability, we could really reduce the reinforcement in the use in the construction due to, as ACC has less weight, dead weight, so we could reduce over there. So that is why we opted for ACC. AC blocks, sorry.
Okay. And what do you think the speed of construction would be for what you have proposed? How long would it be? How long would it take to keep a system up? Your proposal up?
So according
It
to
is
our
taking
estimate,
1 year.
1 year. Okay.
Yes.
Maybe that's a point to think about how you could speed it up.
okay, sir.
Yes, sir.
Okay. Thank you.
Sir,
But
for
otherwise, very
speeding
nice.
it up, we have tried and used like the precast members for the structural members. The framework is of precast and the infill material is of ACC blocks. So that is how we have combined it.
Okay. Thank you, and thanks for the very nice presentation.
So I would like to add one thing. As you mentioned in the first, we have also given the overhead tank. So we have used their submersible pump to pump up that water into overhead tank, and then it is passed through all the domestic use.
Okay. Okay, clear. Thank you.
Thank you, sir.
Thanks,
Thank you so much.
Vinay. So we have our team's project partner as well here. Mr. Sharad, can you hear me? Are you with us? Mr. Sharad, can you hear me? I think you're on mute. Yeah.
I can hear you.
Yes. Now we can hear you. Would you like to comment on your team's presentation?
Yeah, I'm very more than happy about the final outcome and the way the team presented. First, let me make it very clear that this competition was well planned, and by participating in this competition, the whole vocabulary of the participant really changed. They started analyzing the building more rationally, logically, and in a scientific way. These are difficult times because of COVID. We couldn't interact physically more, and also there were constraints for them to move around. So most of them were working from home. The job of the faculty also became difficult. But with all these limitations, whatever points were discussed with them in the initial stages, that they should divide the building into different, apart from designing aspect, different parts about energy, about water, about and all those aspect they research quite well. They absorbed the technical terms and started using them. In between, there were differences of opinion because it is a group work and everybody had different suggestions. But they also want to learn. They learn to work as a team, and the success goes to the faculty who was quite involved, and also the team leaders who learn to tolerate each other and come up with a combined result. congratulations to all them. And I said I would say, end up with saying that I was more than happy and could learn some modern techniques from them. Thank you.
Thank you.
Thank you. Thank you.
These
Thank you. Thank you, Sharon.
these lessons of teamwork are end of the day as important or more important than technical lessons.
Yes,
Very, very
absolutely.
Right.
Yeah, absolutely. So, folks, that was our last presentation for the Community Resilience Shelter Division. So, our esteemed jury panel has shown great dedication to addressing and assessing all these entries. I want to thank these jury members for their thoughtful assessment and comments, and I want to also congratulate all the finalists for having reached this stage. So, as the jury coordinator for this division, I've had the opportunity to see these teams do their deliverable 3 and then their deliverable 4. And all these teams have done a really incredible amount of work, and they have really discovered a way to collaborate and do integrated design at such a testing time. And it was not easy because they were physically away from each other for most part of the year. I think about 8 to 9 months, and I think that itself deserves a round of applause. So this evening, the jury members and the jury coordinators will get together to decide who the divisional winner would be, and also the runner-up teams. So who will it be is the question. So I guess we'll have to wait for that until tomorrow. So meanwhile, I think everybody can make sure that you have visited the YouTube channel to vote for the People's Choice Movie Award. And you can vote for your favorite movie on the YouTube channel. And you can feel free to hang around in the platform lobby. There is also a quick network zone where you can interact with all the other people in the platform. And also, don't forget to visit the project exhibit that these students have put up. And yeah, so see you all tomorrow at 10 a.m. for another day. And well done, team. Well done, all the finalists. And thank you, jury members.
Thanks, everybody. It was a pleasure.
Yeah. Thank you. Thank you so much.
Thank you so much.
Thank you. Take care.
Yeah.
We can leave the studio now, huh?
Yes.
Thanks, Sridhar.